So welcome everyone, and tonight we'll be talking about light, dark, and radio quiet skies, and we'll get into why it's needed and why some of the efforts to achieve this have sort of fallen on deaf ears, and they're getting a little panicky as to how they have to promote it to get people's attention to make them take action on it. Things may appear a little different tonight. I'm on a newer computer with a different camera, and I have to get things set up differently, but I've spent a lot of time recently trying to get ready for the upcoming lunar eclipse that will occur tomorrow evening, Sunday into early morning, Monday a.m. So I haven't had time to iron out all the bugs with the niceties of my recording studio, but
the video is beautiful.
It'll get better. It'll get better over time, but there's some odd angles of like where the camera is and how much of my sort of green screen that now looks like it has blue spots in it because the previous camera was infrared overly sensitive. So I had to put some blue into the backdrop. And when I do that on the new camera, it goes green, got it, blue, got it. So, we'll fix it. Just give us time. But as usual, first we'll do the news. This week we have the black hole picture from the Milky Way galaxy, Sagittarius A star. I think it's kind of funny that they call it A star and M87 star when it's a black hole and there's no star actually there. But okay.
Was a star a long time ago.
It used to be a star, now it's a black hole. Sagittarius A star looks a little different than M87. The degrees of spatial aperture of the two objects are roughly the same. M87 is far larger, but it's farther away. Sagittarius A star at the center of the Milky Way is much closer and much smaller than M87. But the end result is the field of view for the radio telescope array, known as Event Horizon Telescope, comes out roughly the same. I did see a video on YouTube that was done by Derek at Veritasium. They have a very good explanation as to the details behind the image and why it looks the way it does. I also saw a similar explanation by Dr. Becky, but I think Derek's on Veritasium is better for general audiences. The question I originally had was, if it's at the center of our galaxy and we're looking towards it across the plane of our galaxy, why wouldn't we see it edge on? And if you watch the Veritasium video, you'll understand why it looks the way it looks. It is edge on, but the light actually wraps around, so you see the light that gets absorbed in the center from whatever angle you're looking at. So that's why it looks like you're not looking at it edge on, even though you are. Now the clumps around it, there is debris in clumps around the black hole, which produce more radio noise because they're being heavily ionized as they're dragged into the black hole. And so you have multiple clumps, whereas M87, you just have, I guess, two smaller clumps that aren't, they're farther away, so they're going to be dimmer, but apparently they're producing less radio signal. The hard part about doing the Sagittarius A image was, in the center of the Milky Way, there is a lot of debris noise that interferes with us getting good images of it. So the angle of the field of view is a very tiny fraction of an arc second. And you need a synthetic aperture telescope that's the size of the Earth in order to capture that data for post-processing it. And you capture petabytes of data per day per telescope. And then you unplug those solid state drives, disk drives, and you ship them physically to the Very Large Arrays Data Processing Center to convert them into image. So they took 5 years worth of images, radio images, not optical, which was just grayscale data. They packaged off all those solid state drives every day to the Very Large Arrays Processing Center. Now we've got a collection of 5 years worth of data. We can start post-processing it. and then they post-processed it for several months, and they knew they were getting close to it a couple of weeks ago, and that they had, an improving image. So this is the end result. And I've got to do the analogy and say, can't they get it in better focus? Reminds me of one of those UAP infrared pictures where the Tic Tac is out of focus. And it's not because it isn't the most advanced technology radio telescope array that Earth has. It's so far away, and there's so little signal, and it's polluted by debris. This is really an amazing image. But remember, it's grayscale, and it's artificially colored to give you these different colors of red and orange and yellow and white. The picture actually was just shades of gray. And the James Webb Space Telescope is getting towards the end of its final commissioning activities. And no new pictures available to show. But what they did do is create a laundry list of all of the instruments and what they can do, as far as this is a camera, this is a spectroscope, this is a coronagraph. So, if you want to know more about the individual instruments with just a one paragraph overview of them, they went through all 17, is it? All 17 of them. And for those that want to know, well, where is the James Webb Telescope in the sky? I've got a go-to telescope. I've got an imager. I want to go out and see if I can get it. I found a website, theskylive.com/JWST-tracker. And apparently they keep this thing up to date. But as of right now, the James Webb Space Telescope, what's the saying? You are here. So that's where it is in the sky. And they have the right ascension and declination for it based upon year 2000. So if you put those coordinates into your astronomy software, you need to remember to set it for J2000 and not J now, because J now will be off compared to that. That's the Julian date alignment. But that's where it is. It'll be a little tiny grayish looking dot crossing the sky far quicker than any other object that you see here.
Do you know the magnitude?
Yes, the magnitude is not available. See right here? And it's in your favorite constellation, Ophiuchus. No, the magnitude will vary based upon the tilt angle. So they keep the coordinates updated, but they don't update the magnitude because it's going to be variable. But if you go to the NASA Horizons website, you can do a search for NASA Horizons. There you can enter in information about what you want to look at, like JWST, where you want to look at it from: Earth, United States, your state, your city, and then it will give you similar sorts of information. And I think in that, they actually give you an estimate of the magnitude. But remember, it's just an estimate. And SpaceX was having a busy week. They had a Starlink mission, launched 53 satellites from California on the 13th. And if that wasn't enough, I think they're trying for records here. They launched another 53 satellites from, instead of California, they launched them from the East Coast. They launched them from Canaveral. So in 2 days, they launched 106 satellites from 2 different launch locations. So let's see somebody top that. In the same week, they also returned their 4-person Crew 3 Dragon flight. So these are NASA astronauts. They arrived back, they splashed down off of Florida Friday. So you had 2 Starlink launches and splashdown of 4 astronauts all within 2 days. Busy, busy, busy.
Well, I think Korea's launched, 3 or 4 things today? And that with all the COVID going on.
So I could see this coming from a mile away, so to speak. Apparently, the clandestine hearings that the U.S. House of Representatives had with the DNI, the Director of National Intelligence, that cleared the way for, let's do it publicly now. So they're going to have testimony from 2 Pentagon officials in a public House Intelligence Subcommittee meeting. So the public will get to hear everything except the questions you want answered by the House, and they're going to grill 2 Pentagon officials. I'm sure they've already set up all the right questions and made sure to not ask the wrong questions.
That's 7 a.m. Pacific time, which would be what, 10
Yeah.
a.m.
Yep.
our time, yeah?
It's meant for spectacular congressional public hearing observing.
I'm not sure where I can observe it, but I'll figure that out.
The House of Representatives website should tie you into the online session.
Oh, cool. Thank you.
I mean, it's a public subcommittee hearing. And then after they do that, they'll have a private one as well, a clandestine one. Why would you need a clandestine one if it's not the U.S. military doing this?
So you can leak the information like the Supreme Court?
This one, they're trying to get actually out in front of the public.
Uh-huh.
Things are becoming more and more disclosed, which bothers me a bit because they're disclosing the things that, well, you should be asking questions about it. But they don't ask those questions because never ask a question for which you can already suggest what the answer should be. And if you don't want to hear that answer, don't ask the question. I think I did an entire thing on that where, if you don't want that to be the publicly conveyed answer, just don't ask the question. So if there are UAPs and the Navy's got images of them from video, those aircraft were part of a fleet and they came off of an aircraft carrier. Did the aircraft carrier's radar pick these up? I'm guessing that's one of the questions you won't hear asked. Here's another one. One of these things came up out of the Pacific Ocean, flew around, and then disappeared. When it was below the surface of the water, did the submarine detection system, which is part of the Navy fleet, pick these up? Because remember, on fleet maneuvers, you've got subs, you've got aircraft carriers, you've got sonar buoys, you've got low-flying aircraft looking for submarines. This is the military. Come on. And all you get to see are these, outdated infrared camera images from the jets. As Neil deGrasse Tyson says, show me some current technology pictures. My iPhone has a better camera than these things.
That's right.
He's kind of half right and half wrong. He's half right in that, yes, the instrument design on these things is 10 to 20 years old. So yes, we do have much better infrared cameras now. These were taken by Super Hornet aircraft. You don't see any F-35s or F-22s taking these pictures because they do have better cameras. And the second question is, if you are the U.S. military and you have an unknown opponent, wouldn't you ask questions like, what are their offensive and defensive capabilities?
Uh-huh.
Got any information on that? How big is the opposition? Not in size, but quantity. Because I watched the videos and they were seeing many of them, not just one. So when you saw many of them, how many were there? The kinds of questions that if you're really a military, you would ask without having to be told to ask. Hey, that's something that's unknown. They could be in opposition. What's their threat level? How many of them are there? Don't ask the questions for which you don't want to hear the answer.
Well, that's Marco Rubio is supposedly heading up some of these questions.
Actually, it was Marco Rubio at the time, a couple of years ago. He was actually the intelligence it says committee. It's actually House Intelligence Subcommittee that he was the leader of at the time. And he was the one that sort of suggested, shouldn't we have the DNI be looking into this stuff and report back to Congress? And so he's the one that spearheaded the drive for the original closed door session. And after the closed door session, they didn't get any answers better than any stuff they already had. So now we're going to do a public session. But given that there's a change in leadership, he's no longer head of the committee. I don't know who the head of the committee is, but apparently the House Intelligence Subcommittee will be grilling to Pentagon officials. I'm sure they won't be like head of the Navy and head of the Air Force because they won't know anything. They're just the guys in charge. What you need to ask is, I want the captain of the fleet at the time of these observations. That's the guy you want to grill because he's the guy that you can ask things like, did you track these on radar? Did the fleet track them on sonar? How about the other one, which is, so rumor has it that some guys landed on a helicopter and took away the disk drives containing the recorded information. Could you confirm or deny that? And if you confirm it, who were they and what authority did they have you over you as captain of the fleet to take data from the military.
Mm-hmm. And where is it?
These are committee meetings specifically designed to make it look like your elected representatives are on top of it when they're not really. But that's your government at work. Let's go to the other approach, which is universities with money. Have you heard of this one? The Galileo project. This is a project, a funded project at Harvard University. And what they're saying is, we're going to perform a systematic scientific search for evidence of extraterrestrial technological artifacts. We're not going to look at any of the Navy videos or any of the data that is historical, because that's old stuff. We want new stuff. We want scientifically technical new stuff. And they don't give you any explanation as to what they're actually going to do. I'm sure whatever questions were asked by Congress, the Galileo project will have answers for them. But
Would they be checking out things like the supposed doorway that they found on Mars?
if you've ever heard of the concept of a lava tube, that's
Uh-huh.
simply a lava tube.
Well,
So-
it's
So if you have a lava tube and then you have an asteroid, a meteor impact the lava tube and create a crater, the tube is going to look like a hole in the side wall of the crater.
yeah, it's a pretty straight line,
Yes, and we even have those on Earth.
cleaved straight line.
Yeah,
On the moon, too.
we have those on
It's
Earth.
packed up.
It's where the bottom of the lava tube is going to be denser because you had tons of lava sitting on it.
Uh-huh.
Bottom of the lava tube is going to be denser. So when the asteroid hit, it couldn't scrape out all of the bottom of the lava tube. So it looks like a roadway. And at the end of the roadway, in the sidewall of the crater, you have a hole. It's a doorway. Now,
Yeah.
it's just the part of the lava tube that is still underground, but because the impactor tossed up all the dirt and left the roadway, the pillar, which is denser than the upper part of the lava tube, and the roadway takes you to what's left of the lava tube in the side wall of the crater. Yeah, they've explained these before, and yeah, those can even happen on Earth.
Uh-huh.
So yeah, I looked at those and went, I can explain it in a heartbeat. It's not a mystery to me, and I'm just some guy looking at things on the internet. Anyway, the question I have for the Galileo project is, if you're looking for evidence of extraterrestrial technological artifacts, I got a place in South America I want you to visit. It's called Pumapunku. And I want you to look at the H blocks, look at their precision and uniformity. And then I want you to look at the holes that are drilled through the H blocks. And these holes are about as big around as a pencil. And they go through several feet of granite, precise, same diameter, smooth interior from one end of the H block to the other.
Oh.
And we don't today have the ability to do that with all the technology we have. They tried doing that through granite to say, sure, this is the tools that they had. We use diamond drills, and microscopically you can see that the diamond drill created a rough surface on the inside. We tried lasers, and the laser, because it melts the rock, left these little ripples down the length of the tube, which are not in the H blocks at Pumapunku. They even tried plasma torches, microplasma torches. But again, it created a lot of debris inside the hole, which is not at the stone at Pumapunku. So, gee, those rocks have been around for several thousand years. What technology did they have back then that they could create this hole? But I'm sure the Galileo project will say, no, we're looking for the drill bit, or we're looking for the hand drill that did this. That's their definition of technological artifacts.
Uh-huh.
The hole itself, I guess, is not an artifact. I would think the hole is evidence of the existence of an artifact that you should go look for it. But, I'm one of those people that don't mind asking questions for which I can guess the answer, and you don't want that answer. We have no technology to reproduce that. Maybe it's from an earlier civilization on this planet, or maybe it's from elsewhere. Keep a looking. And in a confirmation of something that I talked about a few weeks ago, The Perseverance rover has identified that water existed, flowing water existed on Mars much earlier than they thought, for a longer period of time than they thought, and it took a lot longer period of time for it to all dry up. It didn't like flash disappear. It took a long time, like, we're talking maybe hundreds of thousands, if not millions of years. It would be there longer, disappear slower. And now the Chinese rover, Zhurong, their rover is saying, hey, we're confirming what's already been stated, but we're confirming this on a different place on Mars, on Utopia Planitia.
Oh, cool.
So you now have two things that have confirmed it. I'm waiting for somebody to say, yeah, but that's not proof. We need a third thing.
Well,
Well,
if
we
they
do have
found
the
the boat, that would prove
We
it.
do have the Curiosity rover in addition to the Perseverance rover. So we could have a third thing confirm it, but don't ask the questions for which you don't want to hear the answer. Because if Curiosity says, yeah, we've kind of come to the same conclusion from looking at the rocks, water was on Mars sooner in its history, lasted longer, and disappeared more slowly. And once you have three of them, what's the excuse now? Well, you really need a fourth.
I remember reading about they found evidence of water on Mars, but I couldn't find when they said it. When did they say actually, oh, that's actually H2O?
Yeah. They've already discovered water currently on Mars in two forms. One is the lander. It wasn't a rover, it was just a lander. It had a little scoop. And it was at the South Pole, near the South Pole of Mars, in the South Arctic region of Mars. And they took the scoop and they dragged the tongs of the scoop along the ground and exposed, maybe half an inch of dirt. And underneath the dirt, there was permafrost. And as soon as the sun hit it, the permafrost vaporized because low atmospheric pressure. And as soon as the sun hits it, it warms up a little bit. So it all turns to water vapor and disappears. So that was the first confirmation that I had heard of water on Mars. The second one was, if you've ever seen the image, they'll show what they call rivulets. These are places where there's permafrost under the edge of a large mass of soil, and that leads to a ravine. So there's a slope, and as the sun hits the side of the slope, the water in permafrost starts to vaporize out, and it creates these little black wiggly lines down the side wall of the cliff. So you can look for rivulets. These are like little tiny rivers that don't last long, but they're proof that there's still water on Mars today. It's just not ocean, not lakes, not oceans, but
And it's not really just pure water, it's brine.
it's very salty water.
Wasn't
Now,
that when
if
they
you-
said they looked like trees, but it was the rivulets?
Yeah. If you look at them upside down, it'll look like a silhouette of a tree as dark against a light-colored array of rock, and the rock is just the side of a cliff that has a very deeply inclined slope to it.
So they can manufacture pickles on Mars once we get there.
Well, that's the thing that they're saying is, if there's permafrost, then we want to go there, drill down through the surface so we have access to the water, so we can use solar radiation and electrolysis to split out the water into hydrogen and oxygen, which liquid hydrogen, liquid oxygen, you've got rocket fuel. But also liquid oxygen, you've got something breathable. Liquid hydrogen, you've got something you can use as a burning fuel in case you want to run machines. So finding water and having solar power to split the water into constituent hydrogen and oxygen is very meaningful for future bases on the moon or Mars. And here's an example of, gee, that's surprising, but you could have kind of guessed that. They took soil from the Apollo return missions and attempted to grow things in them. And what they found out was, well, you give it some sunlight, you give it a little water, and yes, things will grow in it. But the lunar soil is so nutrient poor because of the lack of organic chemicals that things don't grow very well. They grow what they refer to as a stunted. And I'm thinking back to the movie. Let's see, how would you get the Martian soil to be better equipped at growing things? You just add human manure, because that has the organic and the nitrogen and things like that. They would act as a fertilizer. But if you know fertilizers, that would be a very hot fertilizer. Hot as in chemically aggressive. So you would have to actually dilute it down in order to use it as a palatable fertilizer for the plants. If you
But
ever,
the issue of this research that you're showing is that because the water or the soil on the moon is so dehydrated that it repels water, so it's difficult to get the soil actually wet enough to grow something or even put a NPK on it. So the issue is that the hydration state of the soil, it gets to repel water. Water doesn't really absorb. It actually makes like a dust covering of the drops of water.
and in
it
fact, you
makes
can see one
difficult
right there. You see this little
Yeah.
round blob? That's actually from this syringe, the water dripped down into this tube, and the water just made a little puddle, a little circular puddle on the surface because the soil was not ready to accept the water. Hydrophilic?
Hydrophobic.
Hydrophobic, yes. Hydrophobic. You can add water, but the water won't mix with it because the soil is so dried and parched that the water cannot break its surface tension to be absorbed by the soil. So if you add materials to it, you're not only going to have to just add it, you're going to have to blend it. So you would need a manufacturing process to create organic soil by taking the lunar dirt, adding organic materials, and adding water, and then just in a tumbler blending this stuff until it eventually cracks it. And then you can use it for growing things. But remember what I said?
Monroe,
Yeah.
when I was traveling to different countries, when we would go to different countries, they would tell us not to go to certain places to eat certain foods because it had human feces with it. They say people that live in that area and grow up with that are used to it, but our floral gut would not survive.
It will if the manure has been sterilized through a heat process. You might want to do a Google search on a product called Milorganite. Milorganite is human manure from a sewage processing plant that has been sterilized and is a component in fertilizer.
Yeah.
And they branded it Milorganite.
So like China, 30
No, here
years
in the
ago,
US. Here in
30
the
years
US.
ago in China, do you think that they were using that? Because
Oh,
that was
yeah.
one of the places that it was.
Absolutely, absolutely. And it would contribute to, the food that you grow in this environment. If it's not a sterilized organic material, it can have bacteria in it that would be something that would make you very sick and maybe kill you. So, proper treatment of the plants that you grow is something you have to look out for. And simply because something is organic is no assurance that it's free of bacteria.
True. And so my question is you think that at 30 years ago that it would have been okay to eat in those places, that they were saying that human feces was being used at?
I wouldn't.
Okay.
When I was in China,
how they cook.
I did question some of the foods because I couldn't recognize the source or how it was processed. But I also looked at it as if it was something that I could see lots of people actively consuming it and they came there on a regular basis. The only thing I had to worry about then is the flora difference of their gut versus my gut. And I have no way of evaluating that. So I would, even if I just, go to Europe and I look at some other food, I'm always going to evaluate it as, do I know where it came from? Do I know how it was processed? Are other people eating it? My way of judging a good restaurant, even here in the US, is if it's not a brand name restaurant, but there's no assurances on that. Hey, Chipotle, or Pollo Tropical, or Taco Bell. If you see it as a particular ethnic restaurant, if there are a lot of the locals eating it, and they look like they visit there often, it's probably a safe place. But then there is the difference between the flora in their gut versus the flora in your gut. And if your gut is more protected, you may
And
have
that's what
you may have diarrhea from it, but you're not going to die from it or get deathly ill.
they were just recommending that we didn't do it because
Yeah.
they said people that lived there were used to it,
Yes.
but that they found Americans didn't, or foreign people actually, because it was a big screw. They said
Yes.
usually foreigners don't do so well with it.
Well,
So
it's
I
a
was
bit-
cautious, but I was adventurous too. And
Yeah.
I did enjoy the different foods that they had there. So thank you for your answer. I was thinking, at first it hit me that I didn't think that they would use this on the moon,
Oh, yeah.
but it says, yes, it will be.
it's a very common practice to use human waste as a component in fertilizer, but you don't want to use it directly because it's chemically very aggressive. Whenever you go to buy fertilizer, you'll see 3 numbers on the bag, and that identifies the relative quantity of components, phosphorus and nitrogen and things like that. If you see a fertilizer that's labeled as, like 444 or 666, it's kind of okay for general use. If you see something where
NPK, the 3 numbers is nitrogen, phosphorus, and potassium.
yes,
Yeah.
but if you see any of those 3 numbers above 10 or in the mid-teens, there's special purpose fertilizers to jumpstart soil, and you probably want to wait for the second crop on that modified soil before consuming it.
Milorganite will really green up your lawn, but
Yes.
it will smell bad for a couple weeks because of
Yeah,
its
I mean, it's manure. But
Yeah.
as I was growing up in South Florida, we also used to use muck. Just go out to the Everglades, and there were trucks that would haul long bed trucks full of just go scrape off the grass and get, feet of muck and then take it to a processing plant. And you could ask for it to be sterilized or not sterilized.
By the way,
And-
stop planting grass. Plant some cover crops like sweet potatoes and stuff.
Yeah. If
I went to the sewage plant, and what they do is they run all the sludge through a big centrifuge to dry it out,
Yes.
and then put ultraviolet light in there to sterilize it. But the only problem is that tomato seeds will still continue to grow. So if you see the piles of dried sludge or Milorganite,
Yep.
they'll have tomato plants growing out of them.
So that's what we need to do. We need to be the Johnny Appleseed of the Florida Everglades and just take tons of tomato seeds and spread them out over the Everglades.
Yeah, there you go.
Now, when
I have
I-
a tomato.
They have Florida tomatoes. They're like a weed.
Everglades tomatoes.
Yeah, they're
actually-
little and green.
I have some of those. I have some of those. Yeah.
one of the problems I had over the septic tank at my parents' home is that it would grow anything there really fast. And
Yes.
sometimes these fruit trees would grow up on it.
Yes.
And people would want to eat the fruit from it. But I would be very
No.
skeptical of them
No,
eating the
because
fruit.
there's generally a foot or 2 of soil on top of the septic tank. So it's more the leached chemicals than it is the actual raw sewage itself. It's probably safe, but what do I know?
Oh. Well, I didn't want to take a chance, so I didn't let anybody eat it.
Well,
Oh, I
remember,
would
any place you go and you drink the water, and it's not a place you're normally existing in has the potential for having a different biological environment, different flora than what you're used to, and that will give you nausea and diarrhea. It's not going to probably kill you, but
My dad came back from Hawaii,
Yeah.
and every once in a while he'd get deathly sick,
yeah,
just deathly sick, and finally some doctor figured it out. He had amoebic dysentery, that the amoebas would clean out of his system, then grow back
Yep.
and make him sick all over again.
yeah. It's kind of like deworming humans. If you have dogs, you know that you have to give them certain pesticide pills to deworm the dog. People go through the same thing. If you have amoebic dysentery, you have to take toxins into your system that will kill the amoeba.
Oh yeah,
Albendazole and metronidazole.
Yeah,
yeah. Well, back
the
after
pharmacist knows for
they
sure.
didn't know what it was,
Yeah.
because they didn't see that over here in the United States. You know,
Well,
and
There's a lot of diseases that are rarely seen in the United States. They're usually from other environments where they haven't modernized to the point where, you know, everything must be sterile.
But I think it's not even the bacteria, because if you do well managed disposal and do the recycling and do the compost made of human feces, the bacteria is not a problem. It takes a year for you to be able to use again, and you need to put like a dry carbon on the top, and that is like the management rules to do that. The only risk is when we use manure or feces from humans from cities. There have contamination of chemicals like medicine and antibiotics and stuff that cannot be killed by the normal processes. So it's like managing worms and bacteria. You have processes that can be done. The problem is when you do that for humans, then it makes it a little bit difficult to remove some medicines and some agrotoxics from the.
That's one of the reasons why post-processed sewer water can only be used for watering plants, and why the city of Fort Lauderdale has a offshore outfall problem. Even though they process the water, there's still pharmaceuticals left in the water that they can't introduce it back into the drinking water system, because they don't want everybody getting Prozac or everybody getting chemotherapy. So they just shove that pharmaceutically polluted water offshore, and there are fish growing around the outfall that are mutant fish. You know, they don't survive long, and they don't.
And they have a project going on up here at Deerfield where they're piping water in from the waste sewage waste plant down off of Copans to Quiet Waters Park, and putting that in the water there,
Interesting.
using that for irrigation and stuff.
Yeah. I know they get it for cheap because the processing plant's got thousands of gallons per day of what are we going to do with this, somewhat processed water. And they create plumbing systems in cities just for irrigating plants. You'll often see along city streets, city and county roads, you'll see grassy islands in the center of the highway, and you'll see little signs saying the water used to irrigate this is post-consumer water, which is a weird way of saying sewage.
Gray water.
They'll go to all the trouble to create secondary plumbing systems to distribute this gray water.
Yeah.
And I look at it as, originally we had one sewage system, and we did not have a separate system for stormwater runoff. And we found that it really makes sense to have two separate systems for that. Don't combine them, because they really need to go different places. And when they get done processing, they're two different outfall products. Well, we're now finding the same sort of thing of gee, the gray water that comes out of that, you can have your regular tap water, and then you can have gray water. And you don't want the gray water system getting into the drinking water supply, but you don't mind using it, on the road behind your house to water the lawn.
Right.
Yeah, but we have technology, just it's very expensive to do in cities because they do that on the space station. So
Yep.
it can be done. The problem is that is the slug that it's left over that cannot be, and they put it to burn in the atmosphere as they use the water, but slowly, but can be done. And the other
Yes.
problem is that those systems work for maybe, the areas where you're trying to figure out how to survive on Mars or in the space station, because that you're going to have billions and billions of investment. But on cities, that becomes a little bit more expensive. So what they do the filtration that is economically viable, to remove most of the danger stuff and dilute whatever is dangerous. But it can be done. It's just depending on the size of the plant and how it's going to be used. Sometimes gets
On the
very-
space station, they do it as a matter of astronaut survival to have a sufficient quantity of water available so they can spend millions of dollars for 10 liters per day of water. But in the case of metropolitan areas where you have millions of liters of water per day, nobody wants to pay the water bill to have that level of processing. So it gets good enough, and then they use it as a symbiotic relationship of, hey, we've got a lot of gray water left. We don't have to drill wells to irrigate the highways. We can just pump around the gray water. It's different baselines for different systems. And when you have a small enough system and an almost unlimited budget, yeah, you can do it. There's no technological barrier to doing it. But when you want to do
You
it
have to be
very large,
careful about drilling wells around here because you get the saltwater intrusion.
Yeah.
Yeah.
Not only the saltwater intrusion, I have a neighbor to the north of my house that he came in and he found out that the homeowner didn't have a sprinkler system. Unheard of. How do you make your grass green if you don't have constant irrigation? So he went in to get a well, and he put a well down, and he went the normal, 70 or so feet to hit water in Florida, which is a piece of cake. But what he didn't realize was that's the iron-rich top water. So he started using it, and his sidewalk and his house turned bright orange.
Yeah.
Then he had to pay a lot of money to get a salt filtering system to take the iron out of the water so that he could then have another contractor come out and clean his sidewalk and clean his house. And now his water's, good enough for watering his lawn, but unfortunately it's not deep enough to give him fresh drinking water. So he's still on city water for his drinking water use.
Well, the part of the problem that they have these orange groves that they are trying to convert over to subdivisions and to sink, it gets ungodly expensive because the wells have to be dug so deep to get past all the levels of fertilizer that were used in the agriculture settings.
You have to be over 1,000 feet down in order to get potable drinking water that only needs mild filtration.
Yeah, it's cost prohibitive.
Now, for a subdivision, it's probably okay, but for an individual homeowner, that's like, close to $10,000 just for the hole in the ground.
Yeah, that's ridiculous.
Until we come up with the plasma drill.
Yeah, it's a lot more
technology behind it.
Oh, well.
Yep.
Pardon the expression.
Yeah. No fun intended. Okay, that's all the news I've got. Anybody else have any things to talk about? News? Okay. Let me pull up the...
Yes, I have it.
You have something. What do you have?
I have dinosaur stuff. Let me give you the link for my Facebook page that I posted. You can post this one. Okay, so let's see. You can start in here. So I'm going to give you the link, and then you can present controls.
Okay, let me find chat.
Monroe. So
Yes.
I placed the link already for my post on Facebook, but before that, I want to tell that whatever the Palma it was explaining this post, it was the discoveries of the dating of the dinosaurs exactly, and also the discovery of pieces of meteorite in chondrule. So it's like a really cool research of, maybe 5 years or so. And that is the area that we want to visit in North Dakota, the Tunney's River area, the dry river. They call it Tunney's because it's similar to the
So this is where they found fossilized dinosaur bones at the same layer as the results from the Chicxulub meteor impact.
Yes, and also they found chondrules with the piece of the meteorite in those chondrules were like from tektites that form, and then that is like the spherules that inside they found a piece of the meteorite. And so there's like a bunch of things they found together. They found animals with that breathe, or the gills of the fish, and they found the chondrules. So they found few animals who died because of that. So that was very difficult for you to find a specific animal that was dying because of that. They found the layers are a little bit lower. There were like layers that they found other animals, but they wanted to find, that was an awesome discovery, is to find animals who died because of the tsunami, or who died because of asphyxiation, or who died because they got burned or something, the effects of all the stuff. And then this is just a picture showing the important people. Are you showing the picture already? The first, hold on.
I think I
I'm not
am.
seeing you.
Can't you see?
Did you got, so can you move the picture to the side, like back on the other side? You can turn one side or the other. So this is so that's the layer.
Yep.
Yeah, and that's the Palma, Robert de Palma. By the way,
The light color is the iridium. They're looking right below the iridium.
yeah, and this is the clay that was deposited on the top that it was coming from tsunamis, and so that's really cool stuff. And go ahead, one more.
The gang.
Oh, and that's the gang. So the guy on the back is the son of the physicist, and he was a geologist. So that's father and son, the Alvarez, who figured out that the iridium layer. So they were the ones who figured out. And then Jan Smith, Jan is, but it writes with J. So it's Jan Smith. His, I think, is Norway, or I forgot where he comes from. He's not American, but he is the one who discovered the different flora from the ocean. So the phytoplankton and zooplankton differences during the time, plus the iridium layer when the Alvarez brother, son and father published their papers. And then those two are Robert de Palma. I know him because he's Floridian, and he's like a famous archaeologist, anthropologist. So he's the one who kind of figure out the areas. Like he's a scientist and he's a Floridian. So, and the other guy, I forgot his name. And can you
David
read
Burnham.
that?
It's on the right. It's on the right side of the
David
screen.
Burnham. So I don't know what David Burnham did, but his might be one of the guys who worked with Robert de Palma. So this is like the layer where they have lots of discovery. And those people are like, I didn't know Robert de Palma before I started following him on Facebook because of the new stuff. But I've been following Alvarez and Smith for a long time. I'm super fan of those two. And then for you to understand everything they discovered, all the perspective and everything that is done, I advise you to go on PBS and watch NOVA. They are doing they did 2 chapters, number 6 and number 7, that are showing the whole discovery, the dinosaurs apocalypse. And so there's 2 chapters. You gotta watch that, and then don't wait to watch. Maybe I think it is gonna be posted till tomorrow, because on PBS, if you don't have the signature, if you don't pay for the the pay now thing, they leave 2 chapters that you can watch for free. So after Monday, you cannot watch the number 6 anymore. You can only watch the number 7 and number 8. So be aware, if you want to watch it, just watch today or tomorrow, because it's super awesome. So it's Dinosaurs Apocalypse. It's really good and explains all of those guys did for us to understand how we don't look green and we have bifid thumbs.
And the reason why they pull the video so quickly is the producer is WGBH Boston. That's who produces Nova. And they actually sell, DVDs of the programs, and they sell it as a streaming service to other channels. So they're only going to let you see it on PBS as a teaser, and then you start telling other people about it, and it disappears. And now the only way you can see it is pony up or subscribe to the service.
You can watch for 2 weeks for free, but after that you get.
That's what I'm saying. But after 2 weeks, they take it off of free public access in order to make money off of it.
Yeah.
Because these guys need a living.
I'm cheap, so I do that. But it's even if you're gonna buy it, totally worth to have in your collection.
Yeah.
Because it is beautiful. The work of 60 years of work and a lot of cat fights of geologists.
I've seen those. Yeah. It's not pretty when you have cat fighting geologists.
A cat fighting geologist with physicists.
Yes. And the guy that came in and showed them all about it was an oil prospector.
So I put on the link, the PBS Dinosaurs Apocalypse. It's 2 chapters on Nova, and you gotta watch it. It's so good.
Has it already been pulled down?
Yeah, they have, but I've got them recorded.
Yeah.
So for you to watch it, you gotta go on and click it, and then you have to tell which station you watch.
I just did.
Oh, okay. Then
Yeah, I have 6 and 7.
Yeah, 6 and 7, but they're gonna pull out next week. So I advise you to watch today or tomorrow, because it's Sunday.
I have them recorded, so.
Oh, okay. Oh, all right.
I record Nova.
So that's two worded chapters for you to see. Dinosaurs Apocalypse is super awesome.
Okay. So anything else before we get started?
I posted a video with a demo on Facebook of the lunar and solar eclipses with the sun.
Time and date. Time and date. That's what I wanted to do. It's preview time. Preview time. I'm going to show you a quick preview of tomorrow night's presentation. So while we're just sitting there watching things, I have a presentation I'll show tomorrow night. And there's actually the link that Helen was referring to on date and time. Anyway, time and date is always a good place to go if you're looking for lunar or solar celestial events. You tell it where you're at, and it tells you all the details.
Time and date.
So here's the model of the moon and the Earth and the orbit of the Earth around the sun, all of the angles. And then here's the explanations of the difference between a solar and a lunar eclipse.
Yeah.
And here is the distinctions between a penumbral shadow and the umbral shadow. And then the perturbations of the tilts and the positions over the 29 or so days of the lunar orbit around the Earth, and why you don't get, a lunar eclipse every 2 weeks and a solar eclipse every 2 weeks. And then for the eclipse for tomorrow into Monday, here's the actual timings. So these are what the astronomers refer to as the touches. This is when it begins the penumbral, and then when it goes into umbral, and then when it's at totality, and then when it comes out the other side. And then, stuff that's obvious. And Helen's video on YouTube kind of says the same thing. Like, if I hold up a model of the moon as just a sphere, and I have the sun on me, and the sun is on the moon, the light on the sphere that I'm holding in my hand is going to be of the same phase as the moon. So, just matter of fact kinds of stuff.
Mhm.
And then, of course, we have to explain how, yes, the Earth is round. How do you know that? Well, let's see. During a total lunar eclipse, the curve of the shadow of the Earth goes over the moon. Of course, the moon is also a sphere. So you could say it's curved because the moon's a sphere. Well, if the moon's a sphere, you're not allowing the Earth to be a sphere. So the Earth is flat, but the moon is a sphere. I think what we're dealing with is two spheres. And then for those that want to do a screenshot to get all the numbers in a quick shot here, this is the timeline for tomorrow evening. So about 8:30, we'll start with our Zoom session. I may fire it up at 8 just to make sure everything's working. So our BA Zoom session will be tomorrow at 8:30 p.m. And that will start with just us, but then I'll also break it out at 9 p.m. into Facebook Live, and the moon, the end of the penumbra at 9:32. So everything is staged. Here's the program for tomorrow night, assuming good weather. And then my trials and tribulations over negotiating for the ability to use this as an observing site. Well, it's a public park, so you can be there, but you cannot conduct an observing event and invite the public to be there. But it's a public park. Yes, but you don't have a special use permit, which literally means you don't have the multi-million-dollar required liability insurance policy. Because my telescope might fall on somebody. Okay, I get it. So we'll do remote live broadcasting. We'll do it on Zoom and on Facebook. But what are we going to do? Well, we're going to need a telescope with a camera. We're going to need a wide field camera. We're going to need a camera for just looking around and seeing what the hell we're doing. And some of this will record to make time-lapse videos. And yeah, that took me most of the week getting all this stuff together.
Wow.
Here's the stuff, all the bits and pieces. And okay, I've got some electronic stuff here and setting it up. And how do you power all that from the field? Well, you put together a power budget. This is what all the different things consume. And what I have is 2 contemporary technology lithium iron phosphate batteries with inverters in them. And they're 296 watt. And if you want a 296 watt one from a no-name company in China, it's about $200. If you want a brand name that's rebranded and you want it to be 300 watts, 4 more watts, but you want it to say Honda on the outside, it's $500 for the same underlying technology. But there's a difference. The power sources that I use actually have 4 DC power outlets and a cigarette lighter jack and 4 AC power outlets. It's got a little inverter built into it, as well as 4 USB charging ports, including USB-C, high power USB, and 2 regular USB. And a horribly bright white flashlight. I've got 2 of those, and you can see they're B1 and B2, and they have DC and AC power, so I can provide it all. But how do you get connected back to the internet? You need mobile internet service. And how do you do that if you're out in the middle of nowhere? Well, you go look up on a website where the nearest mobile phone tower is, and you realize that your service provider is AT&T 4G LTE. You look to see if that tower supports it, and then you look to see from where you're going to be doing the observing, what is the compass angle from that, and then you put 2 Yagi antennas and a phase offset sort of in a D shape, where one's polarity up and one's polarity down. And you put those on a telescope mount so that you can steer it towards the tower while you're watching the wireless signal strength. Not Wi-Fi, but the 4G signal strength. And when you get it to the peak, you shut down the telescope mount, otherwise it will track. So you shut down the telescope mount, and now you have a much stronger signal, higher gain, higher speed. I was amazed. I did this from inside my house today, and I was getting 26 megabytes down for no extra fee. I'm accustomed to getting, at a minimum, 6 megabits or 10 megabits normally, but 26 megabits, I'll go for that for no extra cost. And this was the piece of cake that I don't know that I'll have time to get working. There are a lot of parking lot lights at this location. And I said, well, gee, I can just build a PVC lightweight frame, furniture grade PVC, lightweight frame, and I can drape some black polyethylene sheeting over it to act as a light barrier, which is probably okay for what I'm doing because the moon is very bright until it's not, and then it's bright again. That's the lunar eclipse. But I designed a light barrier. So anyway, and I provided the links for it. So this is what I'm actually going to be presenting remotely from that location, as well as, so Windows 10, the current release, and Windows 11 support the ability to define an IP camera as if it's a webcam. So all of a sudden, my networked IP cameras can be configured to appear in Windows, so I can actually call them up from Zoom as if they're additional webcams. So this is Skycam. Let's see if that, yeah, it's out of focus at the moment, but you can see my camera is now Broward Astronomy, and it's this flickery fuzzy thing. That's one of the two cameras that I'm going to have tomorrow night. And then Scope Cam is the telescope camera, and that will, it's right now got a cover over it. That will be inserted into the telescope, and you'll be able to see the moon in that one. You'll be able to see the moon in the other one, but it's tiny moon going across the sky. Or I can switch back and say, let me show you the regular camera. Ta-da, we're back. So I'll be able to switch cameras, and then I have a Raspberry Pi computer, one of the little chewing gum stick sized Raspberry Pi 0Ws. It'll actually be periodically grabbing still images off the two astronomy cameras, one for sky view, one for telescope view, and it'll be storing that on the flash drive, the 32 gig flash drive that's on, inserted into the computer, so I can process those stills into a time-lapse video after the fact. I did something similar to that when we did the solar eclipse at Fox Observatory. But anyway, that's a preview. So good evening once again. Tonight we're going to be talking about light, dark, as in, reduce the brightness of the sky, dark, and quiet, as in not audible, but radio quiet skies. And the reason why they're needed and the efforts to do it, the organizations associated with it, and how some of their initial efforts kind of fell flat, and the ends that they're going to try and get more people involved and have some empathy for their plight. So here's a new term, cosmological environmentalism. Everybody's familiar with environmentalists, and they just sort of throw in that they're Earth environmentalists. Well, as we get to the moon and Mars and other things, you have to shape that word environmentalist to say, environmentalist for what environment? Well, the atmosphere above the surface of the Earth to the edge of space is an environment. That environment is where your information comes through in order for you to have Earth-based observing of things in space. You're doing cosmological observing, and the atmosphere is something that you want to protect as a critical resource for your observing. And so you have cosmological environmentalism. And there's actually an article down there on it. So there's two particular bands of the electromagnetic spectrum that are used for recreational and scientific observations. The first is the visible bands, or the just offshoots of visible, like near infrared and near ultraviolet, or UVA. So we want the sky to be dimmer so we can see dimmer targets in space through the atmosphere. And then when you're listening to the sky in radio, you want the radio sky to be radio quiet so you can observe very faint signals from very distant objects. That signal has to come down through the Earth's atmosphere for the receiver to pick it up. New approaches to dark sky awareness, because dark is now dark and quiet. So you'll often see something that might appear confusing until you sort of walk through the numbers here. How we evaluate the electromagnetic spectrum is via either wavelength or frequency. Wavelength is the measure sort of in a sinusoidal wave where you're measuring the distance between two peaks or two valleys, and that gives you the wave length. And these are very small values, but in very low frequency radio, the length of these waves can be miles, all the way down to fractions of a millimeter, as they refer to sub-millimeter radio. The second thing you can have is frequency, or the number of times per second that the peaks and the valleys occur. So you'll often see, if you're a ham radio operator, you might hear bands by their wavelength. 2 meter is a common one. Or you might hear it as frequency, how many megahertz or gigahertz. This slide explains how you get from one to the other. They're not directly usable as the same value. So if you have something measured as so many megahertz, you can't say, well, it's the same number in nanometers. Nope, you have to convert it, and the speed of light gets involved because the speed of light is your conversion factor. So if you have the frequency of something, that's going to be the speed of light divided by the wavelength. If you have the wavelength, it's going to be the speed of light divided by the frequency. And different scales are different levels. So you may see things measured in typically nanometers, but once you get to smaller values, you might see microns. But when you're measuring frequencies, you can see any of the normal metric kind of scaling. So you'll see kilohertz and megahertz and gigahertz. And as we get to even higher values, you'll see terahertz. But these are all values that are still well below infrared and visible. But the numbers get to be very large when you get to very, very high frequencies and very, very short wavelengths. And there's just too many zeros. So you have to use these scale factors. But when you're measuring it as frequency and you put in the scale factors, it's still too big a number. So they start truncating off the fractional values. And for example, 299,792.458 terahertz. You don't need the 0.548. Just call it 299,792 terahertz. They're going to have to come up with another number because you'd rather just say 300. I don't know, what's about terahertz? So it's much better to be measuring these very high frequencies, very short wavelengths in nanometers. Nanometer works really well for visible light, all the way up until X-rays and gamma rays, where you start talking about fractions of a nanometer. You know, if we're doing radio observing and visual observing, nanometers is good. It works universally between light and radio. So let's think about what bands of the electromagnetic spectrum are actually viable for observing through, because not all wavelengths pass through the atmosphere. The atmosphere has moisture, water vapor, as well as a variety of gases. Some of them are actually absorbent or reflective of the radiation, the electromagnetic radiation. The parts of the atmosphere that reflect or disturb or scatter are the mid to deep ultraviolet at the very high frequency, very short wavelengths. So that's UVB and UVC, X-ray and gamma. And then on the opposite end, below visual, there is mid to deep infrared. That's why we have our infrared space probes like Spitzer and like James Webb Space Telescope. And we put those well outside the atmosphere so they can do middle and deep infrared. And then you have radio telescopes which are all over the map because there's some notches that will bounce the radio. So it's good if you're transmitting up from the surface for it to bounce down so you can reach to other parts of the surface. So sometimes amateur radio operators will like that ionosphere bounce, but then the radio astronomers don't like the ionosphere because it filters out, because the same thing that allows a bounce won't allow it to get down through. So there's certain things. So a cosmological environmentalist will always avoid attempting to improve the observing through these obscured bands. So for the obscured stuff, we'll send the spacecraft out to high levels of Earth orbit, or we'll send it out to L2 or someplace like that. So the focus should be on what we can receive from the surface of the Earth, or what we need to look through to receive from the surface of the Earth. And let's pay less attention to parts that we'll, via physics, never be able to see. And here's a picture of that. So you can see at the top, the curve where at the top you have atmospheric opacity 100%. So gamma, X-ray, and the high end of UV just will not pass through the Earth's atmosphere. And when you get into deep infrared, there's a notch there that won't pass through, which is why Spitzer and JWST are out beyond the Earth's atmosphere. And then radio, sure, certain parts of radio, you can see the little bumps there, certain parts of radio make it through, and we can receive that from the surface of the Earth. And then when you get to very, very long wave radio, the water vapor in the Earth's atmosphere blocks that. But you see between deep IR and radio, you see that little bumpy curve there? Think about it for a moment. Direct TV satellite broadcasting. Oh, sometimes when it gets to be heavy rain, you get rain fade. Well, that's because the radio wavelength fits inside droplets of water and therefore absorbs the radio signal coming down from the satellite to your receiving dish. So you have some frequencies that the wavelength is just the right size to fit inside water droplets, so you get attenuation, you get that bump coming up there. And others works just fine. So let's talk about the light level, the light band, or the portion of the electromagnetic spectrum that we think of as observing as visible light. It's a wavelength from 380 to 750 nanometers. Think of it as violet through red. And I always like to go from short to long, small numbers to big numbers. So in order for us to capture this wavelength, we need some kind of camera. But for the visible range, we can actually just look up at things that are bright. But you can't do that where there's a lot of light pollution. And light pollution can take all sorts of forms. It can be in the near infrared level. So whenever you look at a piece of electronics and it gets hot, hot is essentially code for infrared emission. So it creates a not visible to human eyes, but infrared fog of emission around the object. So it's hard to do near infrared observing where you have a lot of heat sources. So if you think of, well, we put optical telescopes in the desert because it's drier out there, we can see better. Can't see in infrared because until late at night, the desert produces a lot of heat coming up. So it creates an infrared fog around your telescope. So you wait until the wee hours of the morning when the ground, the soil, the sand and the rock have dissipated all their heat, and now you can see better. But think of illumination devices. As we get to brighter light bulbs, or broader spectrum light bulbs, they're emitting more and more waste in the near ultraviolet range. You can't see it with your eye, but every time you buy that brighter white, daylight white bulb, it's not only producing that bright white light, it's also producing a lot of near UV light, which is invisible to our eyes, but affects us. So there's kind of a presumption that if the folks that want to make the sky darker can do so within the visible range, then although it's invisible to people, they can easily, once they get that bright stuff curtailed, expand it out so they get a little bit of that near infrared and near UV for the actual observing. Maybe they can do that, maybe they can't, I don't know. Same thing in radio. In radio, it's referred to as radio quiet. And this is one of the confusing aspects for the general public is when the public hears quiet, they think audible. They don't think of radio quiet. So when you talk about you want the skies to be dark and quiet, yeah, I like to go out in the Everglades where it's dark and quiet so I can observe the night sky. No, not that kind of quiet, radio quiet. But unlike naked eye observing in the optical band, you need an electronic device of some kind in order to be able to observe at all in the radio band of the electromagnetic spectrum. So you need an antenna, an amplifier, and a receiver anytime you want to do this. And your receiver and antenna must be tuned to a specific band that you want to receive. You cannot receive extremely broad spectrum and then just find what you want in it. Cosmological objects produce all kinds of radio emissions at a variety of different frequencies. So magnetic fields in the atmospheres of planets, neutron stars or pulsars, and radio galaxies or quasars, they're always emitting radio signals of some kind, not intelligent radio signals. It's not like ET phoning us. It's just natural emissions. And you can pick these up in radio bands, and different kinds of things make different radio frequencies at different levels of power. Because all of these natural phenomenon produce radio signals, this is why astrophysical science needs to be able to hear these very faint, distant radio signals. So we need to find a way to hear that without hearing all the locally originated stuff. The locally originated stuff can either be, us, radio, TV, all kinds of stuff that we're putting out in the electromagnetic spectrum, or it can be, if you don't build that transmitter very good, you have a poor electronic design, or if you have a radio receiver that has a internally poor electronic design or poor shielding, it can produce interference that's not intended, but is emitted. And depending upon what you want to receive, there may be untoward emissions that are unintended that are affecting your ability to do your radio astronomy. So that's why you find the big ears, the big dishes put in places like a valley surrounded by mountains, and the mountains are metal-rich mountains, as in there's a lot of iron ore in those mountains. So it acts as a Faraday shield to prevent the outside world radio noise from getting into the sensitive radio dish for radio astronomy. But they also put them at very high altitudes. They put them in the Atacama Desert at nearly 14,000 feet in South America. There's a radio array there called ALMA, and ALMA looks in the sub-millimeter RF bands for radio signals from distant objects. These are, quasars and galaxies and magnetic fields of planets and such. But that's what they have to do. To make it even easier to do radio astronomy from places other than isolated valleys and very high altitudes, the organizations that police and monitor radio frequencies have said, you're right, that's a significant frequency for radio astronomy. We're going to create slices or allocations in the electromagnetic spectrum that will be reserved or for shared use for radio astronomy service, or RAS. They've set aside these bands, and the International Astronomical Union has a Commission 40 on radio astronomy, and they interact with the International Telecommunications Union, which represents 350 nations around the planet, to say, hey, everyone, we've reserved the following frequency ranges or wavelengths for radio astronomy. Or because it's infrequent and maybe you don't have local interference, it's shared radio astronomy. So if you're on a band that's been reserved exclusively for radio astronomy, then if something is emitting in that range and you're picking it up with your radio astronomy receiver, you can go contact the FCC and say, hey, they're in my band. They should stop that. And they can be reported, fined, or sent to jail if they really persist in doing it without any mitigation. So if it's radio frequency interference and it happens to be on a band that is shared for radio astronomy use, resolving this is a matter of cooperation between parties. That's like saying, if the guy with the radio is doing amateur radio in a band that is for shared use with radio astronomy, and the radio observatory comes by and goes, hey, would you stop transmitting on that frequency? And he goes, that's my licensed band. That's what I transmit on. How do we get you to stop? Hey, it's a shared band, buddy. I'll tell you that I do it in evenings. And if you want to do your radio astronomy stuff in the daytime, go to it. So that's not really a cooperative relationship, but that kind of thing can happen is slices are shared, and therefore the parties have to cooperate as to who can listen or talk when. But it turns out that radio astronomy as a scientific process would really like to listen on any frequency it finds of interest from 13 megahertz all the way up to 1 terahertz. Whether or not that range of frequencies has been set aside for exclusive or even shared use for radio astronomy. So because they find something interesting, they want to listen on other people's bands. They're not transmitting, they're just listening. But then they want to complain that those other people need to stop transmitting. They need to stop producing that signal. But it's their band, not yours. I don't care, we're radio astronomy. We just don't like you doing that. So they're identifying stuff as radio frequency interference when they're completely legal to transmit in that range. It's just it hinders their science observations. So how do we mitigate this RFI stuff? Well, there's a couple of ways. We can shield, we can do notch filtering, we can locate the source and complain about it, or we can try and come up with mutual cooperation. Shielding is pretty simple. You've often seen this open wire mesh that is of a certain opening, a certain size opening. For example, you'll see a large diameter radio antenna dish, parabolic dishes, and sometimes you'll see that the dish is porous. It's got screen wire essentially, and that's for the longer, the wider wavelengths. They won't actually fit through the holes. The wavelength is larger than that, so they'll reflect off of the dish and you'll be able to focus the signal. But if you want to receive a higher and higher frequency, you need a more and more solid mesh, finer mesh, or you might need solid metal. But if you do solid metal, that works at any wavelength. You can do notch filtering, which is you create an electronic circuit that will literally drop wavelengths on the floor if they're above or below a particular band pass, a particular band you want to listen to. So if the RFI is interfering with a licensed radio station, as in a radio or TV station, or let's say a public service like VHF radio communications used by EMS or police, then the FCC has enforcement authority in the US to locate and order the cessation of the RFI and has the ability to assign fines. And if you don't stop, potentially seek the Justice Department to impose jail time for you. So when computer hobbyists learn that, oh, if I wiggle a pin on my Raspberry Pi, I can actually create AM and FM radio signals, and I can broadcast, and I can pick it up on my radio. It sounds like a lot of fun until you pick the wrong frequency, or you have parasitic harmonics that smack into a licensed radio frequency, and then you have the FCC come and knocking on your door, and you don't want that. So it's probably not something you should be doing. there are all sorts of wavelengths allocated for amateurs to do unlicensed transmitting. You might have to have a ham license, but there's no more Morse code requirements. With all that, a lot easier. You just need to understand some physics principles. So if a transmitter is operating within a band identified for its purpose, and it behaves as RFI to someone operating in that band identified for shared use or another purpose, it's up to the parties to cooperate regarding the perceived RFI. Basically, you have to share the neighborhood. Now, it's not the entire electromagnetic spectrum, it's diced up. However, that doesn't stop radio amateur astronomers and even professional radio astronomers from complaining anyway. We don't care if it's not our band. We want to listen to that particular wavelength because a reason, like I want to listen to this particular frequency because if I use spectral analysis of those radio frequencies, those can be molecular signal indicators of, let's say, atmospheres of exoplanets where I'm looking for life. So even though radio astronomy was not initially allocated that particular frequency range, the radio astronomy community still wants to go in and tell people, stop transmitting in that area. But that's my area. Now, go somewhere else. But that's my area. Just like that's your area, this is my area. We don't care, go somewhere else because we've got some important listening to do for atmospheres of exoplanets. Okay, so that's part of the play nice until it's time to not play nice. So the radio astronomy community will often go to like the FCC and the ITU and say, we've got a really important scientific research project and we have to listen in this range. So could you please get the guys that are actually allocated that range to move somewhere else? And sometimes this happens. I mean, they do it all the time for commercial reasons. Think about wireless microphones. For years, there were analog wireless microphones that transmitted at a particular frequency range, and there were one-way pagers that transmitted at a particular frequency range. And because those interfered with 4G future and 5G future communications, and with the future of digital television, the FCC said, we don't care if that's where you were allocated and where you were operating. Throw all those devices away or get them modified because that's no longer a place where you can legally transmit. You're now moved to this band. And the FCC has done that many times. I can remember back when my parents had a boat and we used an analog radio, amplitude modulation radio for long distance offshore radio communications. And the FCC came in and said, no, we want to use that particular frequency range for something else in the future. So everybody get off of AM in that band, and we're going to move you up to VHF, and you must be FM frequency modulated in that new band. Basically, all you people that had the cheap radios, throw those radios away, stop transmitting on them, and go buy yourself a new FM VHF radio, which, by the way, FM at that frequency is not bent by the curvature of the earth. And so your radio, which used to be good for 50 miles offshore, is now good for 10 miles offshore. But you just have to deal with that because that's the FCC rules. So in this particular case, the square kilometer array in South Africa and South Australia, they want to be able to receive in a band that is not totally assigned to them, but they want to receive anyway. And if anybody transmits in that range, they'd like to be able to complain about it and get them kicked off. Well, let's see. If it's some wireless microphones on Earth, that's maybe a few $1 million to go replace that over the whole planet. But if it turns out to be, you would like, let's say, SpaceX Starlink satellites to stop using their allocated downlink frequency. Well, you can't just have them turn on a dime. They'll have to launch all new satellites. Maybe that's the plan. But if you want them to move somewhere else, they've got to launch new satellites and get rid of all the existing satellites, and that could take a decade. But that's one of the things that the square kilometer array would like to say is, we want to go listen to some atmospheres of exoplanets, and therefore satellite downlink frequencies have to change. That's currently being continuously prosecuted by the the ITU as to how do we make this not do this, because as the satellites in a constellation system are orbiting over the whole planet, they will orbit over the square kilometer array in South Africa and in South Australia. Well, as they orbit over those locations, they have to turn their transmitters off. So they go through a dark region. And this is the compromise they've come up with is, well, we're not going to replace all the satellites. You just have to deal with them. So there will not be any SpaceX Starlink service within a certain range of the square kilometer array in South Africa and South Australia, because they don't want them transmitting on the band that they've been allocated. Here's the crux of it. On the top bar, you see SKA low and SKA mid, and then a portion of the SKA mid towards the top and between 8 and 20 gigahertz is down at the bottom in that blue bar at the bottom. Within that, the little yellow slice that's there, 10.6 to 10.7 gigahertz, is actually protected for radio astronomy. In other words, radio astronomy can use this and nobody shall transmit in that range. But right next to it is allocated satellite downlink. And this is, where SpaceX Starlink has been allocated their downlink frequencies in the 10.7 to 12.2 gigahertz range. But then you see in the sort of light pink reddish area there, the slice from SKA mid, where the SKA wants to receive, and we don't care who's there already, we just want to receive there anyway. So kick those satellite downlink folks off that range. You just can't have this happen at the drop of a hat. You have to plan for these things, and they've done their work. The satellite community has done their job legally, and now you want them all of a sudden to just change. It's going to be an uphill battle. If you've ever looked at an FCC allocation chart, this is what they tend to look like. So across the top, you see those numbers turned on their side. Those are the frequencies, in this case, gigahertz. So you can see that this is band 5B, having nothing to do with 5G. This is band 5, subband B, and it goes from 8.215 gigahertz to 16.6 gigahertz in this slice that I've sliced out of the large image from the FCC. And you can see that radio astronomy has shared access here, here, and then way down here. But that's not where they want to receive. They want to receive up in here, where satellites are allowed to be. But also notice that mobile is here, as in mobile phones are allowed to use this. And because mobile phones are a very strong signal on different slices within this, and satellites are even on narrower slices at more fixed frequencies, they can cohabit this, and cohabitation is by things stacked vertically. So you see that, for example, radio location has this entire slice exclusively allocated to it. But radio astronomy has to share here and down here. But most of the places where they have to share, there's space research, Earth exploration, passive or receiving only. So even though it's to be shared, they have no competition. But then you want to step over in here and say, and we'd also like a nice healthy slice out of the fixed satellite allocation. Where are these guys going to go? You can see that all these frequencies are allocated. They're not suddenly going to go find this much bandwidth somewhere else. So the radio astronomy community says, I'd like to listen over there, but you're not allowed to listen over there. But I want to anyway, and make those other guys go away. So it's kind of one party's playing by the rules, the other party's like, I want what I want. Here's another example. People are probably familiar with the latest in automobile safety capabilities, where the car will automatically stop itself if it detects a possible collision. It does so using vehicular radar. Or if, for example, a side impact, some vehicles coming at you from the sides of the vehicle, they have more than one radar on the car. So it can detect when something's approaching from the sides and tighten the seat belts, like prepare for an accident. So there's two ranges that have been reserved for radar for vehicles. One is called short range radar, and that's 77 to 81 gigahertz. Another one is long range radar, and that's for 76 to 77 gigahertz. And these are for commodity devices. So like you don't have to have a license in order to transmit radar signals at these frequencies because they've been allocated for these purposes. But the radio astronomy community says, we also want to listen to deep space things on those same frequencies. Well, you're not even shared allowance for that, but we don't care. Think of it this way. If I've got a radio antenna that's very, very sensitive to these frequencies, and a car with a radar on it turns in the direction of the radio receiving antenna, even if it's miles away, less than, let's say, 10 miles away, that radio transmitter is still more than powerful enough to be detected by that radio astronomy antenna. Because the radio astronomy antenna is attempting to listen to deep space things from, millions of light years away, and the signal is very, 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 very tiny fractions of a watt. Well, you've got something here that might be half a watt to 1 watt transmitting in the same frequency range. That's going to be just a flashlight pointed at the radio astronomy antenna. So the radio astronomy community wanted to come back and say, do me a favor. I want you to limit all vehicle radars so that they can only put out 2 picowatts. And remember, you have micro, nano, pico. So this is not just watts or fractions of a watts. These are trillions of a watt. So 2 trillions of a watt power at 3 meters. That's just not enough signal to clearly discern whether something's going to hit your car or not. So the U.S. National Radio Astronomy Observatory filed with the FCC to say, we want you to stop all vehicle radars so that they can't transmit more than 2 picowatts per cubic centimeter at 3 meters. And we want you to be able to put an ID in all those radar broadcasters so that we can come back and identify who's at fault, like which brand of radar is the culprit, which means you would have to register all those IDs. Well, right now that's unlicensed radar, and they want to make it licensed radar. Licenses cost money with the FCC. So it kills off the commodity nature, which means you won't be able to use these radars in anything but expensive cars. So the FCC came back and said, tell you what we'll do. We'll limit the emission to 1,000 picowatts or 1 nanowatt per cubic centimeter at 3 meters. 1 nanowatt is borderline good enough for the average radar. But what about the long-range radar? Well, turns out radio astronomers don't have any issue with that, so fine. Second thing is they were denied the request for device identification in all the radars. It would just be too expensive for the manufacturers to put the technology in the product and then to register all the vehicles and get licenses for them. So the recommendation from the FCC was, hey, radio astronomy community, why don't you put fences around the bore site, the pointing of highways towards your receiving antenna? And the radio astronomy community said, where are we going to get the money for that? And the U.S. National Science Foundation said, I guess we'll have to pay for it. So you'll start to see fences with very, very fine mesh going up near radio astronomy antennas even though there's no city for 10 miles, because the radio signals from all these automobile radars collectively are going to be so amplitude bright in radio that it will affect their radio astronomy. So this is how
That's
you
what we call it, Faraday cage.
Yes. So they're going to put a Faraday fence around certain radio astronomy observatories if there are major highways that point towards the receiving antenna. In the case of radio band emissions, there is a community that offers federally identified and sanctioned enforcement and regulation for radio emissions. That's the FCC. So as of the Communications Act of 1934, and then later confirmed and improved with the Telecommunications Act of 1996, the US government has established and upheld the FCC to be a federal agency given the authority and enforcement over radio band frequency allocation and transmit power. So not only can they say, if you're doing this, you can only transmit in this range, and you can only transmit with this much power. So you can't just go, I'm going to create a new radio broadcasting widget that does something. So whenever you see things like Wi-Fi transmitters, that access point has to fall within FCC guidelines for frequency range and amplitude, power over that frequency range. So you'll typically find things like Wi-Fi cannot use more than 1 watt of transmitter power ever, and your product has to have the ability to say, I'm in a conflicted space radio-wise, so I have to be able to turn down or attenuate the transmit power. Well, that's just the FCC rules, and somebody who is being affected by your overly radio bright transmitter, even though it's in a band that you're allocated to do that, if it's overly bright, too much transmitter power, you can be reported to the FCC. Back when I was doing hotel internet access, I found that one installer would be more than happy to put a 15 dB omnidirectional antenna on your hotel sidewall so that it would beam the Wi-Fi through the cement rebar walls of your hotel. So within your hotel, you'd get really good signal. But of course, you get the same good quality Wi-Fi signal 3 blocks down the road. Which means that if I was installing in the same Wi-Fi band and I was operating at the 1 watt range, because I put in multiple access points to cover all of the areas, in the area where their transmitter at the other hotel was infringing upon me, I would have to go report them to the FCC. And it would be either the other installer or the other hotel that would have to spend more money to get more access points and more antennas and tone down the power. But the FCC doesn't just go around looking for trouble. Somebody has to report the conflict, the interference. But that's just here in the US. Outside the US, there's 350 nations that are cooperative with the International Telecommunications Union, or the ITU. And the FCC does have filings that they'll send to the ITU. Although the ITU being an international organization, they are free to change or not agree with FCC regulations and actions. And whenever you see a Wi-Fi interface and it says, what country are you doing this in? Well, that's because in the US, Wi-Fi at 2.4 gigahertz is not precisely 2.4 gigahertz. It's a set of channels within the 2.4 gigahertz band. Well, if you go to Japan and you want Wi-Fi, they're slightly off-shifted and there's a gap in the middle of it. And that's because the ITU allows Wi-Fi in Japan to have a chunk in there that's used for other purposes. So even internationally, there are allocations specific to specific countries. But there's rogue operators. Now, rogue operators are nations that are not member nations of the ITU, and it's like being on the open ocean where the pirates can run rampant and there's no international law to protect you from them. So if I happen to be on the island of Tonga and I want to create a satellite network for use in Tonga, I can create TongaSat. So the satellites that the nation of Tonga put in orbit above their island in the Pacific can transmit at whatever level of power they want on whatever frequency they want. And they just said, hey, ITU, here's what we're doing. Take it. And ITU had to say, don't try any of that stuff over other nations that are ITU governed, because that won't fly. So what has happened is there's a constellation satellite company called APT that is creating a competitor to Starlink called APT Star. And because they didn't want to have to go through all that paperwork of FCC filings and being limited to only transmitting on certain frequencies, and we want to do what we want to do, and we want to do it, we don't have to pay any license money. APT Star is under the guidance of the nation of Tonga. So it's kind of like when you see ships and you see, hey, that cruise ship registered in Liberia. Well, why is it registered in Liberia? Because the US maritime regulations cost us money and we find them too constraining on things like environmental protection. So we're Liberian and proud of it. Well, APT Star by APT is registered under the nation of Tonga and therefore doesn't have to obey any FCC or ITU regulations. But they're going to be orbiting all over the earth, and they're going to be providing service to other than Tonga. So how's that going to work? Well, you can't stop them because they're not governed by the ITU or the FCC. So what is the radio astronomy community saying about them? Nothing, because even if they complained, there would be no ear they could take it to that has any authority or jurisdictional reference to Tonga. It's an independent island nation out in the Pacific, but because the satellites that it launches can orbit the Earth anywhere, they can transmit on any frequency at any power. Now, luckily, they've been looking at the bands that are allocated for satellite communications and aren't really being too much of a rogue behavior. So they're kind of being cooperative. They're just not filing all the paperwork and paying the license fees, but internationally it's legal. So unlike the radio astronomy community, the optical astronomy community has no regulatory ear that will listen. There's no equivalent of the FCC for visual astronomy, for that visual band of the electromagnetic spectrum. If there were, then you wouldn't need things like the International Dark Sky Association or the American Astronomical Society or the International Astronomical Union and their efforts to make the skies darker or to keep them dark. So there's no federal agency with governance over emissions in this particular band of visual light. If there were, think about it for a moment. That would mean that every light fixture, every light bulb that you went to buy would be governed by FCC federally identified regulations. And if they were in violation of it, they could be fined or sent to jail in the US. So if you get a brighter light bulb that puts out a lot more, let's say, ultraviolet, you could be held accountable for it if there were a federal organization that had authority over this. They had no jurisdiction over this portion of the EM band. But if you have a smart bulb, which is an electronic device, that's FCC governed for its radio emissions. So the 2.4 gigahertz Wi-Fi transmitter receiver in the light bulb is governed by the FCC for proper power and frequency range of the Wi-Fi signal. But the light bulb part itself, make it as bright as you want, infringe, from infrared all the way up to ultraviolet. But there's a different federal agency, the US Food and Drug Administration. They've been granted federal authority over high output optical devices like lasers and UVC output, as in the case of your Blu-ray player or sanitizers that have UVC radiation, because those are ionizing radiation and they can damage your vision or your skin. The US FDA has been given jurisdiction. Why didn't they give it to the FCC? You'd have to go back and understand where these things came from. But if it's radio frequency and it's non-ionizing, that's the FCC's turf. If it's radio frequency and it's ionizing, that's the FDA's turf, because ionizing affecting people is health, and health is FDA. So I am a believer in keeping the skies dark. I don't like it in my neighborhood, at least, when people go out and buy these ultra bright white coach lights and put them on the side of their house and you can see them anywhere in the neighborhood, or when a certain religious institution near my house puts in tower lights so their parking lots can be lighted by fewer tower lights, and I can literally see the bulb half a mile away in my residential neighborhood over on their grounds. But there's no agency I can complain to. However, because the organizations that are affected by this stuff, by the skies not being dark and not being radio quiet, they didn't get the attention they wanted to by saying, it's bright, I can't see that galaxy, I can't see the Andromeda galaxy naked eye anymore. Have some empathy for my plight. I didn't hear what you said because I'm too busy selling brighter light bulbs and new light fixtures. So they basically became apathetic and took a deaf ear to it. So how do we convince people brightness is bad for you? Well, health. Don't you know that bright stuff in the ultraviolet range can give you cancer? Yes, under certain circumstances, there are evidentially indicators that can be a problem. Or safety. Having a bright light on the outside of your house makes your house so bright that you can't see the criminal when they're standing right in front of you. Okay. Power waste. Well, that's far more light that you're putting out than you actually need to illuminate safely the area that you're in. So it's a waste of electricity. And these are the missions of the IDA now. Is it's not just keeping the skies dark for astronomers. It's the light could kill you, and the light could make the bad guy invisible where he could attack you, and you're wasting electricity. So that's how IDA is adjusting their focus on the negative effects of light pollution. And regarding constellation satellites, the optical astronomy community is up in arms about constellation satellites, and they're working with the American Astronomical Society and the International Astronomical Union to actually have consortiums, to actually have conventions to discuss all this bad stuff. And recently the IAU has come up with this phrase of dark and quiet skies. But they went out and they started talking to the public, and the public thought, sure, I like it to be dark in the Everglades and it's quiet, I can just hear the crickets. No, radio quiet. I don't listen to my radio out there. It's too far away from the city. I can't pick up any of the stations, and my mobile phone doesn't work. That's not the kind of radio quiet we're talking about. So it's kind of missing its impulse. So I think they just kind of tacked on quiet onto dark. And the people that are being affected by it do know the difference between the two. They're just sending the wrong message. Dark, they can understand. Quiet, maybe there's another word you need to pick besides quiet. So here's my favorite FUD from that community. I've often seen images of satellites. There's thousands of them. The satellites that are in Earth's orbit. It's bad. Okay, I get that is an issue if the satellite density is high enough, and if the radio transmitters aren't all Tonga-like and they're obeying the rules, then I don't understand what the problem is. Space, as Elon Musk says, space is big. Yes, and these pictures are all exaggerated fabrications designed to create fear, uncertainty, and doubt. So the left image at the bottom, notice anything familiar about the satellites that are there? Well, I can kind of see it looks like the Hubble Space Telescope's there, but I see a lot of satellites that look like a body with a solar panel off to one side. Okay. Well, what about the huge satellites? You see the International Space Station there anywhere? It's far more light obscuring than any of these communication satellites would be. Do you see any of the very, very large satellites like GOES satellites that are used for weather and they're geostationary, or the TDRS satellites, the telecommunications data relay satellites used by the US military? These are, massive satellites that can only be launched into geostationary orbit by the very largest of rockets. But those aren't pictured there. The second thing is, if you scale the Earth down to the size it is in this graphic, and you scale the size of the satellites down by the exact same ratio, the satellites would become invisible, as in the satellites wouldn't even be the size of a single pixel. They'd be a fraction of a pixel. To drive home their astonishment and outrage over this, you get to pictures like the second one. They start to put more of the satellites that are in orbit. But again, they have a lot of the satellites that look very similar, but they left out the ISS and they left out the bigger, higher orbiting satellites. But they did go to show that some of the orbits of the satellites are elongated ellipses. Those are the ones that are, why are they so far out? Those are not the geostationary ones, those are the elliptical orbit ones. But the picture on the right is actually animated. You can go on a website and it will show you all the satellites in Earth orbit. The Earth is even smaller, which means the satellites are more exaggerated as to making them bigger than they really are. Why? Because if they actually made them the right size and they put all of them there, you couldn't see the continents of the Earth below it. You'd have to make the Earth much larger for the cloud of satellites to be further separated apart in order for you to see through the cloud. But that's because it's scaled so small. But if they scaled these pictures so that if the Earth was shrunk down to this size and the satellites were shrunk down by exactly the same ratio, none of these pictures would have any visible satellites in them. And that just wouldn't, create the level of astonishment or outrage that these folks want to do. So zoom up them satellites to make it look like, oh my God, beware the FUD.
Yeah, but even though they're not big, they're still there, right? I mean,
What's the distance between satellites?
Since they're moving at tremendous speeds, don't they have to avoid other craft that are there? And aren't astronomers' pictures getting trashed by the satellites going across? I don't know. I'm just asking. I mean,
okay.
That's what I read.
It's a good question to ask, and it's good that you're reading it, but you don't seem to be questioning what you've read. Is that because it comes from professional astronomers and you just have an inherent respect for whatever they say, take it at face value?
No, I probably saw it on Fox News.
Oh, okay. But I look at this as, I understand that the atmosphere above the surface of the Earth is a critical resource and is a limited space. But I also understand that you don't just arbitrarily put something in orbit. If you're launched from the US or a International Telecommunications Union governed nation anywhere on the planet, except for maybe Tonga, you didn't put it up there and transmit at just whatever frequency you want. You had to go file for a license to be able to transmit. And there are governing bodies like the ITU and the FCC that say, okay, here's the frequency you can transmit on. Here's the frequency you can receive on. And you are obliged to be there for every one of the satellites you put up there. So if you think about a Starlink constellation network, every one of those satellites has been allocated a licensed transmitter and receiver for communications with that individual satellite. Every one of those satellites in orbit has been allocated by FAA, and International Telecommunications Union actually lets assignments to the FAA internationally. So every one of those satellites has been given an orbit. and they are required to maintain that orbit to the best of the functioning of their technology. So whenever we launch something that has at least 2 stages, a rocket that has at least 2 stages, the first stage will fall back almost immediately. In the case of SpaceX, the first stage is recoverable. In the case of other programs, the first stage may or may not be recoverable. They're trying other approaches like snaring the parachute with a hook from a helicopter. They got it, couldn't hold it, had to drop it. So they're trying to recover the first stage. What about the second stage? The second stage is so high, it can't have enough reserve fuel to come back down and land. So what do? They purposefully burn them up, but the trajectory of their orbit for their short-lived lifespan is FAA allocated. So I'm not concerned as long as we don't have rogue operators. So far, the number of rogue operators are not presenting a problem. So while it may look confusing to the average person, especially that picture there on the lower right, there's just so many of them. What if they hit each other? They are typically 20 kilometers apart vertically and 10 kilometers apart horizontally. And yes, they are traveling at many thousands of kilometers per hour, but then so are all the other satellites in the same orbit. So they are spaced vertically and horizontally. They get slices and stations, and as they get up to there, they are assigned a place where they have to be. If they go outside of that, the FAA will come looking for you. But what about if it's beyond your control? Like recently, there was a very old, probably 15-year-old Russian upper stage booster that was not shut down properly. They had a problem with it after it already boosted its payload out of Earth orbit, but the spent upper stage was still there and they had no control over it. So it left itself essentially fueled up. So when they had a little bit of sun angle on it and it heated up too much, it literally blew itself apart because we used to not manage things as well as we do now. So there's still probably 100 plus things in orbit that were not managed well back then. And I did a proposal and put together as one of the presentations of how you can use lasers to push these errant satellites, errant boosters down so they burn up in Earth's atmosphere. So there's a way to deal with this, but this is not an unmanaged space. Both the physical space and the radio communication space have management agencies. So I am not very concerned about a Kessler syndrome because the satellites are so far apart, even though they're moving very fast, and everything's been allocated. So I don't have the same level of fear, uncertainty, and doubt that some people do. But let's get on to the actual SatCons. The American Astronomical Society did hold 2 conferences, the first and the second SatCon, where this was the cover to the report they put out. And you can see it's by NOIR, which is infrared astronomy, and AURA, which is radio astronomy. And then you have the American Astronomical Society. The first 2 organizations are governed by your tax dollars, the National Science Foundation. The third one is a Society of Professional Radio Astronomers, professional optical and radio astronomers. They put this out as the cover of their report, as if, be afraid, be very afraid. And this is a completely exaggerated cover. Nowhere on the cover does it say not to scale. But if you flip to page 2, there is a block of text in small print down in the bottom of the page that says, by the way, cover image, not to scale. Well, I know the Earth is not to scale, but by saying not to scale, it gives them the latitude to exaggerate the size of the satellites versus the size of the Earth. So if you take the Earth, which is 7,917 miles across, and you scale it down to 5.5 inches, this being on an 8.5 by 11 page, that's a ratio of 0.000001096%. That's how far down the Earth is scaled in this image. If you were to scale the satellites down by the exact same percentage, so apples to apples, there would be no satellites in this image. They wouldn't even be a pixel apiece. So that's an exaggeration meant to produce a result. And I hold the AAS accountable for this fabrication. What you're going to do, if you read the report, you'll also find that they did simulations on the potential reflectivity of satellites for light. And right in the description of their simulations, they said, well, we didn't go to the trouble to actually get all the different photovoltaic array sizes. We just kind of picked a nice large number, and then we used that for all satellites. Well, there are some really, really big solar arrays up there. They're the size of football fields, kind of like the ISS size solar arrays, but they didn't actually use those because that would make the ISS look like a bad player. But what they did do is they exaggerated the size of all of the Starlink solar arrays to be many, many times larger than they really are. They did not take into account the fact that you see giant dish antennas on some of these satellites, and if the sun reflects off of those, they're a parabolic antenna. That'll reflect the sunlight at whatever angle you're looking at it. But the bottom side of a Starlink satellite is a phased array radar. It's flat and it's painted dark. So it's very less reflective than their simulations actually complained about. The second thing they did is in their simulations, they put in 30,000 satellites for Starlink when, as of today, there are only 2,202 Starlink satellites in orbit about the Earth. And they put in 48,000 satellites for OneWeb, which is still fledgling, and as of right now has only 428 satellites in orbit. But I guess they were just projecting a bleak future where 30,000 Starlinks combined with 48,000 OneWebs would just be horrible. Okay, go back and understand that Starlink has no intention of putting 30,000 satellites simultaneously in orbit. They have a license for 30,000 because these things fall back periodically, or they don't work out as planned, or they want to upgrade the technology, so they burn some up. But they allocate licenses and satellites for 30,000 of them, but they're not going to have 30,000. I would say maybe 5,000 would be a good place for them, because they've pretty much, except for some spotty areas, already covered the globe, and they're launching them 53 at a time right now. They launched some on Friday from California, and they launched some today from Cape Canaveral. And these are fill-in satellites. These not only replace ones that were defective that they burned up, but it also fills in niche areas where they weren't getting a strong enough signal. But they didn't launch 1,000 satellites to do that out of 30,000. They launched 53 here and 53 there, and they'll leave some on reserve. So I can understand why they would be concerned, why the astronomical community would be concerned if it's taken to extreme. But so far, there's no indication that they plan on taking it to extreme. They're trying to drum up an audience that is not questioning what they're stating. And I just find that deplorable for the AAS to do it. So here's an underanalyzed image. This is the image from the dark energy camera in South America, the Rubin Observatory. If you look at the image, your first thought is, those streaks are horrible. I understand that. This is a very, very dark site. Why is the background sky gray? Oh, don't ask that question. Because if this is an observatory looking for very dim things at a very high altitude, the background sky would not be gray, which means this image is overexposed. And why is it overexposed? Well, because that way you can see the Starlink satellites. But nobody asked those questions. So I take it to the next level and say, Were these satellites already on station, or were they at lower levels on their way to their stations? Because there's a reason why they'd be brighter. And why is the background sky gray instead of black? I can understand that in my neighborhood. My background sky is very gray because I've got a lot of light pollution. But if you've got a 4-meter telescope up on a very dry plateau in South America at more than 10,000 feet, your background sky would not be this gray. So I did an analysis. I said, if I were the professional astronomer, what could I get from this image? First thing you have to notice is all that black area around the outside edge of that image is unusable because that's not part of the imaging chips. But it looks like there's more black than there should than you can get from this. This is how much you can actually technically get from this image if you're looking for dim things like minor planets that might eventually hit the Earth and you want to calculate their orbits. They're very, very dim. I understand the need to have a very, very dark sky. But what else is in here? You see all the purple areas? Those are pixels that they can never capture because they're gaps between the imaging chips. See the purple rectangles? Those are portions of the imager that's not functioning properly, and they just accept it because these are multi-million-dollar imagers, and sometimes they'll go a little flaky. And when we do our next annual refurbishment, we'll get that fixed. But in the meantime, just mark off that area as not usable. So all the purple stuff is either not usable because there are gaps between the imaging chips. I mean, you don't typically have a 10 gigapixel single imaging chip. You have an array of megapixel imaging chips, and there's a gap between them that you just can't get any image in there because the chips don't abut directly to one another. There's a little bit of gap between them for thermal conductivity and expansion and contraction. So the purple areas are thrown away pixels. What about the green dots? If the goal of the image is to actually spot very, very dim things, then any galaxies, nebulas, or stars that are very bright have to be extracted from the image because they will bloom out any dim things going, in the range of that star. So they have zones where any pixels in that area have to be ignored. Now, how did I find out all this stuff? Because there was a space probe called Kepler, and it was looking for exoplanets. Exoplanets are very small changes in the brightness of very far away, many, many light year away stars. So if you're looking for a very small pinpoint star and you're looking for the brightness to dip very slightly for a brief period of time, and that's your way of noting there could be an exoplanet there. And then you take the amount of dip and the duration of the dip to calculate how big the exoplanet is and how close to its star it's orbiting. If that's what you're trying to do with this Rubin telescope at this very high altitude with this very light sensitive camera, then take out the blue areas. There's no imaging chip there. Take out the purple areas as defective parts or gaps. Take out the green areas as these are places that are too bright for you to be observing any dim things through. How many pixels did you just remove? Versus how many pixels are there from the constellation satellites? And are these constellation satellites always going to be there? Or is this just during the 30-day period when they're getting up to their normal station? If so, I can imagine they might be like this. You notice any other satellites? So as an amateur astronomer who's done imaging, you go out in the Everglades in South Florida shortly after sunset, you get satellites in your pictures, and you take a stack of images. You might take, a couple of hundred images if it's a CCD camera. You might take 10,000 images if it's a video camera, and you might have to throw away a couple of your CCD stacked images or hundreds of your video images because of satellites going by. I don't see any satellites here other than the Starlink satellites. What about the other satellites? Well, because the software algorithm for processing the image already took them out. It knows where the satellites are going to be, and it creates little black streaks where there would have been satellites. Some of these are natural dark areas in the sky because you're looking in visual light. So this area here and this area here, you can see these sort of dark splotches. That's, you're looking in visual light, not infrared. So this is just gas and dust obscuring it. But if you look closely within this image, you'll find some places where there's just little black dashes, like right here. See that little black dash? That could be a polar orbiting satellite that the software that's processing the image said, let me take the satellites out. It went to an international database. It got the coordinates of the satellites and said, yeah, that's that one. Let me take that out. Now, because it's an astronomical research image, you can't just merge the pixels together and sort of blur up the location. You literally have to black out the pixels. So that makes little tiny spots where there are satellites. The satellites that are in higher orbits move more slowly, but they can even be brighter. So the satellites that are at geostationary orbit that are much larger and much more reflective because they have larger solar panels and parabolic dishes, they could actually be producing far more reflectivity than all these constellation satellites, but you won't see them because the software processing algorithm removes them. What are the odds on this field of view, which is probably 20 degrees by 15 degrees in size? And where are all the other satellites? Because they've been removed. When they did the second workshop, they didn't have a report. They just had an executive summary. So a shorter document, but this was the cover image. See the star in the center? You see how much brighter the star in the center is? Because it's not just the star, it's also glowing out from the star. Now, if this was taken from a very high altitude, there wouldn't be sufficient water vapor to create that halo effect. But if you overexpose the image, now the constellation satellites look bright. So once again, deliberately overexposed image to hype things up. So how dim do the satellites actually have to be? This is actually a picture courtesy of SpaceX. This is their explanation, and this was part of the report of the executive summary to explain to the professional astronomy community why these satellites are bright when they're first launched, and then a month later, visually, you can't even spot them anymore. And it requires a telescope at a certain time of day to capture some of them going overhead, not all of them. And the reason for that is, if you look down here, when the satellite is first put into orbit, they take the solar array and they orient it so that it's out level with the chassis of the satellite. This is because as the satellite is moving up at its orbital station, it presents less air resistance to the lower atmosphere of the Earth. There would, be too much drag for the ion propulsion that they use to put the satellites up to their orbital station and to keep them at their station. So while they're just orbited and in the month-long process to get them up to orbit, they will be far more reflective. Now, how much is far more? So when they're first launched, they're magnitude 4. That's naked eye visible, which people love to see the Starlink satellites naked eye visible when they're going overhead. But then you come out a month later and you go, where'd the satellites go? Well, they've oriented to this mode where the bottom side of the satellite with the flat phased array antenna that's painted black, that's now what's facing Earth. And the solar array is actually pointing upward or slightly upward, and it moves a little bit based upon the sun angle as the satellite orbits the Earth. So if you were directly below the satellite, only if the sun reflects off the bottom of the satellite and finds a certain small percentage of reflectivity off the dark painted surface will the observatory directly below it actually see it in the sky. So when you're looking at that picture with all the lines, the white lines going across it, ask the question, when was this taken relative to when they were put into orbit? And did you take a similar picture a month later when they were at their long-term orbital station? If they took the picture later, they would go from magnitude 4 to magnitude 6.8. 6.8 is beyond visual range for most human beings. But magnitude is also not linear, it's exponential. So something that is magnitude 4, that is magnitude 5, is now half the brightness, as magnitude 6, which is half the brightness of 5. So when you get out to magnitude 6.8, it is considerably darker than when they were first launched. What the AAS is expecting is about magnitude 7. So the difference between magnitude 6.8 and magnitude 7 may be some more work to do on the Starlink satellites, and then they can get to magnitude 7. Once they are at magnitude 7, supposedly the AAS will have no optical reflectivity complaint on constellation satellites. But also remember that the only constellation satellite system that is currently doing this dynamic orientation of the solar panels to put them above the satellite once they're at orbital station is Starlink. If you look at OneWeb, they're a traditional satellite with sort of the block body of the satellite and then the two ears sticking out the side, and the ears rotate up and down to catch the sunlight. So when they're directly overhead, they have to point their solar panels out at the sun, and when they do that, there's going to be a spot directly beneath them on the Earth that's going to see this bright satellite going overhead, even once they're at their orbital station. The Starlink satellites will be at about 500 kilometers orbital altitude when they're on station. The OneWeb satellites will be probably another 100 kilometers higher, which means they will orbit at a slower speed. So the OneWeb satellites will produce more light for a longer period of time, and it won't get dimmer once they get to orbital station. So I'm waiting for OneWeb to get to the point where they launch their first, oh, hey, they've already launched 400 satellites, but you don't hear anybody complaining about them. Where's the pictures of them? Because they're going to be brighter, and they're going to be at orbital station brighter. So SpaceX is actually cooperating with the astronomical community to point out how things work and how they're doing efforts like DarkSat and putting up a sun panel to reflect the light so that they can be a good member of the community. But I don't hear the AAS complaining about OneWeb. Maybe it's just because SpaceX is willing to be part of the community, and they're currently the ones with the most satellites in a constellation network up there.
Did OneWeb already launch any satellites?
They have 438 satellites in orbit right now. Their satellites are physically much larger than the Starlink satellites. They're at a much higher orbital altitude by over 100 kilometers. So they're slower moving, and their traditional design of cube body, parabolic dish antenna, and flat panels that they can tilt. And in order to, as they orbit the Earth, maintain the sunlight on the panels will be at an angle that when the sunlight reflects off of them, there will be a spot on the Earth that will trace out this bright line, and the line will be far brighter than the Starlink satellites. So I see it as a little bit of a bias towards Starlink, but I don't see any complaints
Who
about
owns OneWeb?
The UK government, an Indian large corporation, and one other organization. They initially went bankrupt and had to be bought out of liquidation. But 438 satellites as of today. So I don't hear any comments from the astronomy community about them. I think there's a bit bias going on here. So yes, a dark, radio quiet sky is critical to this cosmological resource that is the Earth's atmosphere that we use for scientific investigation, be it professional or amateurs, be it optical or radio. I understand the reason for doing that. there are organizations like the FCC and the ITU that do have jurisdictional governance and enforcement authority over radio emissions. And they have specifically allocated bands for radio astronomy. But the radio astronomy community wants to listen wherever the science takes them, even if it's into bands that they haven't been assigned or they have to share with others. There is no government agency that controls and has enforcement authority over infrared, visible, and UVA, which is also where they'd like to be observing. That's just, your dark skies programs of IDA and all these other organizations. There is financial gain to adding to light pollution. The recurring sales of brighter broad spectrum luminaries that everybody wants their light to be brighter and whiter, and through improving efficiencies. When I first put in smart bulbs in my house, they were 16 watts, then 8 watts. Now they're down to 6 watts. So as I rotate through newer bulbs, my energy savings improves. The downside is the bulbs last for years. So when am I going to be replacing a working bulb just to save 2 watts? I'm not. If the bulb ever fails, I'll replace it with whatever's off the shelf at the time, which is going to be brighter white and lower power. So there's a period of time where it's going to get worse. Instead of light pollution, you're going to have mega light pollution in cities. It's going to get brighter, whiter, and that's because there's no governance, no enforcement over the visible spectrum. There is both military industrial complex, financial, and military mission gain in increasing the number of satellites orbiting the Earth. So there are GOES satellites that are geostationary and massive, both radio and reflectivity for weather. There are TDRS satellites that, because the military has to communicate all over the Earth, and some of that communication is also used by NASA. If you remember when I was talking about the James Webb Space Telescope, the Deep Sky Network is used for receiving the signal from the JWST as the Earth rotates in different parts of the sky. But once that signal gets back down to Earth, if it's received in Australia, the most expeditious way to get that signal from Australia to California is to take it down from the Deep Space Network to the receiving station in Australia and send it back up to large Earth orbiting satellite geostationary position over the Pacific Ocean that can then relay down to California where JPL is. But then they have to relay over landlines, over fiber optic networks, high speed, to the east coast of the US where the Space Telescope Science Institute is, where all the science is done with the James Webb Space Telescope. So, TDRS is used by more than just the military, it's used by science. So these big, bright satellites are just always going to keep going up there, and the astronomical community never questions them because the government will go somewhere else for your problems, sonny, because they won't give them the time of day, so to speak. And I think that for the general population to gain a greater value over the perception of needing a dark sky, you've probably heard of night sky events where there'll be a lights out period of 1 hour that you can voluntarily obey. And you'll see some lights in a major city go out, but not the whole city. But it won't be dark enough for you to see the night sky as you would in a rural location. So what we need in order to make people have empathy for a dark sky is not to threaten them with biological harm or wasting power, but to say, if instead of having a lights out period voluntary, go at the government level and say, as of this time of day, and it can even be like, 2 a.m. to 5 a.m. on a particular night over a holiday weekend when maybe people aren't going to be out and about. And then you shut down every street light within a certain municipality. Maybe it can be a city, maybe it can be a county, but if you just kill off all the municipal streetlights, all of them. There'll still be enough light from all the businesses where you can see, how to get around in the dark, but you'll be able to see the night sky like you've never seen it before. And people will start phoning into their police departments, "What's that stuff up there?" Because they've never seen a dark sky. Well, be prepared for that. So once the public can actually partake of a dark sky for an extended period of time, they may actually grow to appreciate it. And that's a better approach to convincing them an optically dark sky is a good thing for more than just those astronomer types. To reduce the incentive for a commercial constellation satellite network that is both satellites and radio frequencies, maybe what we need is more fiber optic going to other places, more terrestrial networks like relay 4G and relay 5G, because if I could get service out in the middle of nowhere for a small amount of money per month at a good bandwidth, Starlink's expensive. It's $500 for the receiving station. It's $100 a month. Now it's $110 a month. That's eventually that's going to be too expensive for, aside from the people that have no alternative to using it. So it will be shared use in third world countries that have no infrastructure. It will be exclusive or maybe neighborhood shared use out in rural America where the normal companies don't want to spend money to put silly fiber optic cable to your house 20 miles out in the middle of nowhere. So if there are alternatives, then satellite companies go broke. And if you want an example of that, you can buy a satellite phone like you can buy a regular cell phone. You can actually buy a satellite phone. But the company that does that is going to charge you $1,200 for the phone. And they're going to charge you, I think it's $7 per minute for usage time. And it'll be spotty. So you'll only get your phone to work as the satellite's going overhead. And there aren't that many satellites left because the Iridium satellite network is basically, as long as they last, they'll last. Once they become non-operative because they run out of station keeping fuel or they break and they burn up and can't be usable, then Iridium will slowly have a reduced customer base because nobody wants to pay that much money for a satellite phone that you can only use maybe. But if I can use my Starlink satellite dish to do voice over IP, I can have a voice over IP mobile phone at my house to replace my landline service. I do that now. My home phone is not a phone line anymore. It's actually a VoIP service that has a relay device to my home wiring inside my house. So I use normal phones and I have a VoIP relay box and it puts it out over my AT&T 4G wireless internet connection because phone service is a very low consumer of bandwidth compared to video and other things. So if there's competition that's effective, there would be no need for a constellation satellite offering because they couldn't make enough money to stay in orbit. And as long as you have a dark enough sky for a long enough period of time, people may come to grow to value it and say, yes, I like it when I can see a dark sky. Is there any way I can see that other times of the night? Yeah, if we just had some lights that were better shielded. There's an approach to doing this that doesn't involve fear, uncertainty, and doubt. But that's the angle they're currently taking because their initial science-minded, everybody likes science, science-minded approach just fell on deaf ears outside the scientific community. So you knew if it was a presentation from me, you were going to get all this stuff. But I put links in there to allow people to go off and do the analysis themselves, come to their own conclusions. I could just be identified as a curmudgeon, or I just don't understand the true impact of these things. Like, yeah, I think I do. I think I've done more than a few hours of research into these things and spent time reading all sorts of detailed reports and definitions of how satellites operate, and going, okay, I see the square area of a Starlink satellite and I see the square area of a GOES or a TDRS satellite. Like, why are you complaining about that one where they're trying to reduce the reflectivity, and you're not saying word one about those, which are the size of a tractor trailer rig and have a solar panel, two of them the size of football fields, and they go over the sky slower? I don't get that. Any other thoughts or comments? You can have dissenting opinions.
If a municipality was to turn off their lights once in a while, wouldn't crime go up?
No, actually, as we put in brighter and brighter lights, crime is actually going up slightly, because think of it this way. If I put a really bright light on the outside of my building and it's at 20 feet off the ground, it'll very nicely illuminate the parking lot, but the front of my building will be almost invisible because it's in the obscured bright light of that light. So, my house is actually illuminated by dim red lights. And because of all the other light pollution in my neighborhood, I can go outside any time of the night without a flashlight and see just fine because of all the wasted energy of my neighbors. But do you think anytime soon they're going to dim it down so that I can take my telescope out front and look at dark things? No, because they'd be afraid if they didn't have these god-awful bright white lights. And I would say they've spent a few $1,000s at two of these houses because they got the very large, they were originally filament bulbs, just open wire filament bulbs, very bright, but they weren't bright white enough. So they replaced them with these string LEDs that look like filaments, but are actually just hundreds of little LED chips. And they're extremely bright white. So they've gone from kind of a amber to orangey glow, tolerable, to god awful bright white, and you can see shadows cast across the street. So their house is actually being obscured by how bright their lights are.
And the other thing is that criminals need light to see.
Yes.
So some areas where they remove the light, so some areas that, got a lot of houses being destroyed because there were no people, like during the 2008, 2009, a lot of people lost their houses. So there were like whole neighborhoods got abandoned and they have a lot of criminality. So they put the house down and remove all the lamps because the municipality didn't have money for that. So they just drop everything in some areas. So they figure out that whenever you have a light pole, you have more criminality in few areas than areas that are completely dark, because for you to do any kind of activity you need light, so including the criminals. So there are a few research papers that show that sometimes like excess of light is detrimental, because when you are obfuscated by the light, you lose the acuity of your eyesight, and so stuff that is far away or is on the side of a view, you don't see it because of way too much light. But when when you have a lamp in your house, you put the shade on the top so you can see better. If you remove the shade, every time you go there, you can barely see anything around it, because it's your eyes, just your pupils close and you don't see around. Same thing with very bright light near some areas. If it's glaring you, it's unsafe. If it's pointing down, it's safer.
And there's an old joke that they used to do on skits on TV involving an alcoholic, and he's fumbling around on the asphalt and he extends his arm and he goes, "Well, I'm looking for my keys. I lost them over there next to my car." Well, if you lost them over next to your car, why are you looking here? The light's better.
Sure.
That's an old joke. But yeah, and when they describe bad lights, when you look at the IDA's website and they describe bad lights, they'll describe street lights as a cobra style light or an acorn style light. These are classical light fixtures. You can go on IDA.org and I think it's I actually got it here. It's not IDA.org. It's darksky.org. The IDA is a different company. Darksky.org. You can go on darksky.org and you can find what is a bad light and what is a good light. And they will identify a bad light as one where the light just sort of arbitrarily spreads out to 90 degrees and just covers the bottom off in the distance. So if you have two light poles and they're both spreading out at 90 degrees, they're actually having light impingement from one pole to the next, which would say you don't really need the poles that close together. You can separate the poles and get just as much light on the ground. But in order to make the contractor, charge more for all the poles they put on the highway, you need more poles, more light. So there's a financial incentive to put in more light. The second thing is, don't you want your downtown to be artisanal? You want it to look old-timey? So you want those acorn-style lamps. And the acorn-style lamps there's a hexagonal bar, and then below the hexagonal bar, there's 6 glass panes. And then above the bar, there's 6 other glass panes, and the light bulb is in the center coming from the side or from the bottom. And so the bulb just goes out, a full 360 degrees in all directions, including the sky. So if you look at downtown Davie, Florida, they have acorn lights down the main thoroughfare, down Davie Road. If you look down Davie Road, all you see are the lights. You don't see any of the businesses along the side because the light's so bright and it's directly in your eyes that your pupils go whoop, and you can't see anything except the bright light. So if you're looking for a business along Davie Road and you're seeing all these acorn lights, you have to drive slowly so your eyes can look off to the side of the road and stop looking at the street lights in order to see the businesses alongside the road. So it actually creates traffic hazard by having these stylish acorn lights. The current trend, though, is if you want to get rid of the cobra heads and you want to get rid of the acorns, what you need are full cutoff lights with no direction upward. Makes sense. So the second thing you'll figure out about light poles is when you need to be serviced, if they're really tall, there's an extra cost of getting a cherry picker type truck to come out there to service the high light. And if it's a really high light, they actually put a crane assembly in the tower. You'll see this on the Turnpike and on I-75, where really tall tower lights, they actually have like a flagpole flag raising thing where they unlock it at the bottom and they can bring the ring with all the lights on it down to ground level, work on them, and then raise it back up. Well, that avoids the cherry picker because for those, the cherry picker would have to be over 100 feet tall, and that just gets to be too expensive. But for your average highway street lights, a couple of $100 extra for every light bulb that needs to be replaced to get the cherry picker out there, because you'll do a bunch of them at a time, that's found money on the table. You're not just replacing a $50 bulb, you're replacing a $50 bulb with $100 in labor and $200 of cherry picker per hour. How much money did the contractor charge you for replacing that light bulb? I don't know, several $100s. How much did the light bulb cost? $50. There's a reason to go to LEDs. They don't burn out as often. So when they go to LEDs, they'll get a flat panel luminary, fixture luminary. And what they'll do is they'll have a flat panel, and in the flat panel, they'll have just probably 100 plus individual LEDs in an array. And based upon which model of luminary you buy, it will have, 30 LEDs or 50 LEDs or 100 or 200 LEDs. And if the power level is less, that means the cost to operate can be on par with the older style light that you took out. So if you took out a 1100 watt sodium vapor light and you're putting in LEDs, you've got a 1100 watt power budget. So as long as you come in way under that, you're good. So how many LEDs do you buy in your luminary? The most you can buy at the lowest power that are the brightest white, they will fit within that power budget. So if you find that the companies that make the fixtures and contractors that install them have done the math and said, we're going to have a luminary that will at no point use more power than an old style sodium vapor bulb. Therefore, we can sell you the new fixture, which is lowered to the ground, so you can use just a normal, like 13-foot extension ladder. You don't need a cherry picker, cost reduction in maintenance. Their LED, they don't burn out as often. But to keep the contractor price up, you put in the maximum number of bright whites you can put in there. So if you go out to Everglades Holiday Park, you'll see that they have low lights. They do not point upward. They're flat on the bottom, but they might have 80 individual LEDs in them, and they're all 15,000 Kelvin. So extremely bright, extremely white. And because they're shorter, they presumably have less light angle on the ground, which means you need to put the lights closer together, which means you need more light poles. So they have double the number of light poles that they had before, and they're brighter, but they consume not a watt more power than the other ones did. And because they'll last longer, you can afford to put them in. And because they're shorter, they're cheaper, so you can have more of them. And because they're LED and they're not tall, you don't need a cherry picker, so your maintenance cost goes down. So the formula has literally been shaped to put in the maximum number of the brightest white LEDs you can. And it's definite evidence of that. But that's just my research.
Yeah, if you want to see a good example of light poles, you gotta go to Fort Lauderdale Beach. You gotta see when they have the turtle season, they turn off some of the lights from the business. So the lights is just perfect because it's like a probably orange color. So it might be like maybe even like 5,000 kelvins or even lower than that. It's very like orange light, very agreeable to look at it. And then the luminary covers the whole light bulb.
Yep.
You can only see the light bulb if you go under the light, because they have little fans that actually point the light to the ground where you need to see, and not to the beach where the turtles don't need to see. And the whole ground is illuminated. Everything is illuminated. There's not one part where you step on Fort Lauderdale Beach that is not illuminated.
Well,
But
you
the
have to-
light's just perfect. You don't see the light bulb until you get under the light bulb, under the
You have to
pole.
you have to go to a specific stretch of A1A along Fort Lauderdale Beach. It's at the north end of Fort Lauderdale Beach. It's north of Sunrise Boulevard and south of Pompano, and it's across from Hugh Taylor Birch State Park. That's where you'll see that, because that's a grassy area for turtle nesting. And they use pier top lights, so they're short. They have fins that direct the light to the ground, and they're in this amber color, and they are merely meant to illuminate the walking sidewalk and nothing else. And they work wonderfully. If it's a celestial event that you can see in the eastern sky at night, I would recommend that stretch of Fort Lauderdale Beach over the Florida Everglades. So if you want to see a particular meteor shower or celestial event that's in the eastern sky at night, I'd say go there rather than going out in the Everglades where it's mosquitoes and hot and humid. And, hey, you got Fort Lauderdale Beach right there, and it's nice. There's a breeze, it's cool, and it's dark.
It's
So,
actually darker than Fox Observatory.
oh, far darker than Fox. Fox is now very light polluted, courtesy of the city of Sunrise and the city of Weston, just all the commercial businesses in the area. I watched it get brighter and brighter over about a 3-year period. Literally, you could see over a couple of years things disappearing in the night sky. Fewer and fewer stars were visible, and the sky was getting gray. That's another reason why we looked at Everglades Holiday Park. Is it's farther away from Sunrise, definitely, and it's a distance away from Weston by some swampy area that's miles wide, and it's a bit north of the city of Hollywood. So it's kind of the darkest public site left over. So to see that they horribly put in all those bright white, low, high quantity street lights is, can we turn those off? Well, if you had a special use permit, maybe we could talk about that. But if you don't, sorry.
I remember when they were building 595 over at the observatory around 1986-ish.
Yep.
And that was the concern. And somebody held up his hand, and you could see they had a big hole was dug, and they had a big light shining on the hole, and it shined on the observatory wall.
Yep.
And he held up his hand. You could see his shadow.
Yep.
And that was their concern until they were told, we're not going to use overhead lights on the roads. We're going to use reflective lights on the road. So that was like a victory that we were going to overhead lights.
Yeah. I know that the SFAA worked with Broward County and with the Florida Department of Transportation, that when they were extending 595 and expanding it, there were rules put in place on the Florida Department of Transportation, which went down to their subcontractors and their contractors to only put in certain types of fixtures. And when they put in that giant spaghetti bowl at 75, the Sawgrass, and 595, they put in tower lights. But they put in tower lights with downward facing shielding on them, and they put in tower lights that were orange in color. So they were being as good a citizen as they could be within the goals they were trying to achieve. Yet, when you go west on 595, where it becomes I-75 after you go past the spaghetti bowl, all bets were off. They started to put in horribly bright white lights that would go all the way out to 90 degrees just for miles in distance. And one of the homeowners in Weston actually complained to the Florida Department of Transportation and took the case to them, one step shy of going to Florida court to get an injunction against the Florida Department of Transportation. And the DOT begrudgingly came back in and put shields on only a handful of the lights and only on a certain side of the lights. So if you go west on I-75 north beyond 595, you can actually see these black metal shields, and they have no effect on the roadway at all. But you can actually see the dark sections of Weston where they've darkened up that part of Weston simply because of these shields. I learned from a highway maintenance engineer, I learned of a little trick back when they were doing Cobra style lights. And for a time thereafter, when they changed off of Cobras, why is it that street lights that have, let's say, 400 feet between them, they're not tower lights, they're tall, but they're not tower lights, and they're Cobra style, why is it that I can see the light in a street light a half a mile away? Obviously, the light a half a mile away isn't intended to provide light to me a half a mile away because there's a light right overhead. Why is it that I can see all those bulbs going down the road? Oh, that's for the maintenance team. Huh? Well, it's easier to spot a bulb when it's out if you can see the bulbs. I said, so what's your excuse when they're LEDs? That's just a carryover. So when you look at the bulbs on I-95 through Broward County and you see, oh, they're kind of orangey in color and they don't point upwards, but they still point all the way out to 90 degrees. And you can look down the highway and see bulb, 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 bulb going off for a mile plus. it's their old technique of, I have to be able to see the bulbs from a distance. That way I can file my maintenance report and go, I got to get that one tomorrow. Why don't you just drive down there tomorrow and look for it? That takes time. It's much easier to see them all from a distance. Why don't you put circuitry in the electronics of the light to report back that bulb's out? Because then the lights would be more expensive. Wait a minute. You put light sensors every so often in the string of lights to turn the lights on at dark and turn them off at daylight. Yeah, and those often fail. That's how come you can be driving down the road in the daytime and see a section of streetlights on when they should be off, because some bird pooped on the sensor. And the sensor thinks it's night all the time now. Yeah, okay. Because then it would deny them the $10 per bulb for bulbs they buy in quantity, and it costs them $2 a bulb. Oh, because they outsource the replacement of the bulbs to an electrical contractor. Yeah. If my neighborhood takes the lighting any further, what I'm going to do is I'm going to replace all the lights on the outside of my house with multicolor strip lighting under the eave, kind of like invisible Christmas lights.
Mhm.
So I can have them on red dim throughout the year. And there's actually a feature in Alexa where you can say, tell it to turn these things on at sunset and off at sunrise. And it actually dynamically calculates that time of day throughout the year. So my exterior lights on my house, I do nothing. There's no light sensor. They automatically turn themselves on at the location specific current dark for that time of the year. And I can select how much time after that. So if I go with civilian sunset, I can say civilian sunset plus 45 minutes. Turn my lights on. Civilian sunrise, minus 15 minutes. And I can turn my lights off. And I don't pay for that service. That's just part of Alexa. I know the names of the bulbs around the outside of my house. So if somebody I don't know goes walking out in front, looking at my house or walking around my car, and I see them on one of my cameras, I can literally tell Alexa to change the color of that light to bright white right now. And it does. You ever seen people like move out of the area very quickly? But as soon as they're gone, I change it back to, it's normal dark red. Okay, I do have a procedure that I can command it verbally to do the effect of guard mode. So I can declare a guard mode anytime I want, and it will affect every light in my house. It will affect Alexa saying things on all dots in my house. So if all of a sudden I find an intruder in my house, I can command that verbally from any dot in my house, and my whole house will go into a lockdown mode. And Alexa will basically tell you, your intruder's been detected, and you're going into recording mode, and the authorities have been notified, and it is in your best interest to leave the way you came in right now.
That's pretty cool.
Yeah, that's the kind of stuff you can do.
I was like Mark Rubber glitter bomb.
Yeah, but there's no glitter to clean up afterwards.
Yes.
I also have a recovery word, a recovery phrase that I can announce. So if I put it into that mode and then, they leave, or I discover something just fell off of a shelf and made a noise and I panicked, I can settle things back down to normal.
That's pretty cool. Normally you just have to say, Alexa, I'm leaving, or Alexa, I'm home,
Oh, I've got that. I've got that too.
For me, it was too much noises in the neighborhood. I tried to do it, but it didn't work.
Yeah, I've also got I'm leaving and I'm home, that I can use those. I've got good night and good morning. Those are useful. So when I want to go to sleep, I tell it good night, and it turns off all the lights in the house, and it actually changes the color and brightness of the lights in the bathroom so that if I go into the bathroom in the middle of the night and the infrared sensor picks me up and it turns the lights on, it will turn them on very dim pink so they don't disrupt my night vision. I wish they had more people at Amazon that were focused on some of the astronomy things. Like, I'd like to ask it where the moon is in the sky and have it give me back the azimuth and elevation coordinates.
Ah,
You can ask for, when is moonrise or when is sunrise, when is sunset.
yeah.
It knows all those things. And because it knows where your account home is, it can tell you based upon the current location. Same thing with weather reports. You can shorten it up to just say, Alexa, weather report. And she'll say, currently in Fort Lauderdale.
Yeah, she said, hey, Alexa, stop.
Yeah. Okay, I've been sharing all this time, so I'm going to stop sharing.
Oh.
And we're still recording, so I'm going to ask, aside from all that we've said so far, is there anything anybody wants to say before I stop recording?
No.
Watch the video from PBS. It's awesome.
Stopping recording.